when you click the button, something else happens maybe something happens to the paragraph. And there is a reason why you have to write a unit test on this interaction, and why you need to encapsulate everything under one component that you can reuse again and again as a block element. Imagine you take this block element, the one you see on the screen now, made with love by CMS Driven. Imagine if you can take this block element, change just the copy, and place it to a different place of your page, maybe in a different URL. So by maintaining a UI component documentation, you can get the whole UI UX team, product owners, testers, devs, everybody can get involved. As you can see here, we know how we call the first component. We call it call to action. We know what this is doing because we have some description, and we have a live preview of this component. So we can know about the props that this component accepts. We know how it looks. We know how it's called. So the UX UI team, they can now, instead of creating another component again that looks very similar to this one, they can reuse the same one, because now everybody knows how it's called. They know is the call to action. And because everybody knows exactly how to refer to this component, because everybody have access to this documentation, on their designs, they can say, this is a call to action button. So you can just reuse it. You don't have to redesign something that it looks similar, but it's, like some pixels under, a little bit different on size. Maybe you can make a little bit more flexible on your props, and you just put this, extra parameters. So you can make it in a different size. You can make it look different. So if you go through the route of using this CSS style guide, some of the things you have to consider is using BEM. And this is because of what is BEM? BEM is a block element modifier, is a methodology that helps you create reusable components. And you can have a code sharing in the front-end development without anybody breaks something that already exists out there. So we have the block. The block is one big piece. Can be like the navigation bar. An element is maybe some links in the navigation bar, and the modifier is what we call it modifier. And what this means is modifier classes are the classes which have to do with the attributes of the element. For example, you can have a red modifier, you can have a blue modifier, you can have a large modifier, a small modifier, and then you can combine. I will show you now what I mean. So the card element, the card is a block, so we can use the name convention card. The H1 is the title, so we can use a naming convention called card __ title. Why we using __ title is because now, because we have prefixed it with a card, we can in this way create something like a vendor, it's like a namespace. So nobody else can write something similar that can override your title. Because maybe in some point in your app, you have the title class, and in another place you have, again, the same class, and they can collapse and they can create an issue. So you can have the title attached to a namespace card, all of them together as a one namespace. And then if you see a little bit under it on the P class, you can have card text, which is all the attributes related with a card text are there, all the basic attributes are there. And then you have the extra, so you put another class, which is the card text secondary. This is going to to do only with the attributes of the secondary. So I will show you now what I mean. 1 second. Yeah. So what I mean with this is the secondary button can be a red button, for example, or can be a blue button. So the card text itself, maybe it has to do with where it's positioned, what is the font size. Maybe we want always to have some standard styles, and then we just want to change one only attribute. And this only attribute can be like a color, maybe can be the size, can be something we grouped together and we say this is a secondary and this is a primary. And we can mix and match now. So BEM and Solid, why those two principles are very similar together? This is because every CSS class is written to serve only one purpose. We do not reuse the card class for anything else than the card UI block. So we do not reuse the card for anything else than this UI part. And therefore we cannot have like these bugs of overriding by mistake. And if you take the interface segregation principle from Solid, what this is telling us is telling us that we, instead of having everything into one class, one big class, let's say card, instead of writing just a card, you create smaller classes, what we call in programming interfaces. The similar here, you just create a smaller CSS classes for every single modifier. So instead of creating the card, you can create a card title big, card title small, card title highlighted, and then you can just mix and match. So you have unlimited possibilities. Some of the problems on software development teams, we as a devs, we don't like to make content change. There are too many times like product owners coming back to us asking, you have to make these content changes and you just want to do these images, just replace this image with another one. It would be great if we can focus, in a more complex tasks by building a UI component library and leave all these content changes to non-tech people. This will be a nice approach. So because for their perspective, they want to make the changes very quickly, and we don't want to, we don't want to do these changes. It's not nice for us as a devs. We don't like this. Deploying new pages is usually a very slow process, guys. Every time a product owner asks a developer to make a change, this will take some time, especially in big corporation. This is due to the required extra code you have to do. And there are also some bureaucracies in some companies, especially when we talk about copy changes that we want to roll out immediately, and things that we want to turn on and off very quickly. Let's say something is very bad. We have like a GDPR issue on the website, and we want just to turn off this section very quickly. So normally you have to do maybe use git flow, maybe use trunk approach. You have to do a code change. You have to make a deployment to the server. You have to do this quality of assurance for every code you change. Maybe it's a 2 thumbs up approach. Maybe it's some regression test before you run these changes. So there are a lot of stages, and this is usually a slow process for us. So there is a gap between the tech and non-tech people. In the web development department, there are developers, CTOs, tech leads. All of them consider us a technical. And then there are non-technical people, product owners, copywriters, UI, UX designers. Non-tech people within a company feel helpless, waiting for every single change to be done by us, by developers. It would be nice if there was a way we can bridge this gap between them, right? Another problem is branding authority is at risk. What I mean with this one. sometimes when you go to a web page, you going to a login page and it looks a little bit different from the main website, or you go to a section and looks completely, not completely, but a little bit different. Maybe the colors are not exactly the same hex codes. Maybe the paragraphs are not on the same spacing. You notice the difference between one page and the other page. That's why you need the CSS style guide, because you want to enforce the consistency of how it looks like. So when you navigate through all the website, you feel you are on the same branding. You are still on the same website. I know that some product owners and tech leads, they have decided to use some CMS tools like WordPress just for building the landing pages. The problem here is exactly what I said, is the branding will not be the same, the one from the UI UX team. And there are always limitations. You cannot do everything with WordPress. You cannot do everything with all these tools like Wix. That's why they're hiring us. That's why they're hiring us, because we can do all this custom logic. But they still want to take some benefits out of it, because the benefits of using Wix.com and Squarespace and WordPress and all these CMS tools is because they can build pages quicker. And obviously they can do it in a lower cost for them. But there are some cons doing this. There is no consistency. SEO optimization is not guaranteed, because all of this is spit out just in HTML code. There is a high learning curve for them until they know the tool. And there is no way to implement very, very custom complex logic. And they're using us because of the consistent UI branding we offer, because we can do anything is possible, because we can write everything in React, and you can do anything you want. There's no limitations there. And SEO optimization, because when we write, the H1 is always considered as a title. When we create an image, we put in an alt. So we can optimize it for SEO as well. But again, there are some cons with this approach. There is a, one second, I'm getting a message. Just want to make sure everything is okay.
Yeah, that's fine. I can duplicate it by voice. So
okay, that's fine. Okay, yeah. Sorry, I thought it was you trying to say something. Okay.
Yeah.
Yeah.
So could you provide a simple example of when building a page by CMS could be useful, for example, and show a nice page built with React? That probably would be a better visual example. Thank you.
Yeah. So all the landing pages of first of all the landing pages, all the marketing pages can be built with CMS, first of all, and except of those. But the thing is, the question is which CMS you are going to use, because there is a concept called headless CMS. Headless CMS, it's just an API, so it's not an actual CMS. If you think about it, it's a typical CMS as we know it. You can just drag and drop components, UI components into a page, as we know it from WordPress, Joomla, and anything similar like that we had in the past. You drag and drop UI components into a page, and then you just make code changes. So you don't have to do it manually. You don't have to write down page components, and you don't have to put the component one after the other. You don't have to make this link between the API, the headless API, and your own components. So I will end up somewhere a little bit later what you can use for a CMS. At the moment, what I'm saying is you can use them in all landing pages and all marketing pages for sure. And you can use it also in maybe some, if you have like a multi-page forums, or you can use it. You can even use it for a dashboard, to tell you the truth. But I will explain a little bit later on how and why you should use it. Okay, let's later on this one. Okay, an ideal world. An ideal world will be if we remove all the cons from here and we keep only the pros. So what will look like? Pages will be built quicker with a lower cost, because some technical people will only build the UI components, and for the non-technical people can also change the content. We have a UI consistent branding, and anything is possible at the same time because you build everything in React. You keep having the SEO optimization, but at this time you don't have anymore the slow process. You can deploy very quickly. So this is the ideal world. Let's see some statistics. Traditional CMS is dying. As we can see here, WordPress, Drupal, Joomla, Wix, all of them, they just going down. And there is a reason behind it. And this is because there is no way to implement custom functionality. And everybody just now turn to the UI component libraries and frameworks like Angular, which is a framework, Vue.js and React, which is libraries. And we see right now like a huge increase the last years since 2004, and you can see like a very huge increase to today. Let me just show you something. So this is now where I'm coming. I was back then using the traditional CMS where you have like the everything as one solution in under one infrastructure. Let's say WordPress, you have everything under one project. You don't use React back then. You cannot create live documentation. You cannot test your code. It's bad. The CMS driven is the tool that I have built, and this allows you to create React components in the way you was doing them anyway. So there is no change on your UI components. You just build UI components as you did before. And then you have an online documentation generated, and you maintain, so this UI documentation looks like this. So this is the live documentation. So you have the name of the component, you have a paragraph about what it is, and you have a preview. So back to the presentation, and yeah. So what are the steps to doing this? It's very, very simple. You just have to sign up. You have to download the React boilerplate initially. You can use your own. You can use the existing code base, or you can just download a boilerplate so you can start playing. npm install, npm run start, and that's it. How you build a UI component? The same way you was building it anyway. So here I have an example. I have the made with love component, which it's this one. Let me go back. Sorry for this back and forward. Just to give you an example, is this one. It says the third one, made with love by CMS driven. So what this is doing, one second, it's a very straightforward component. It's just a functional component. You only have to use props as the inputs. So the only difference is like instead of you hard code everything in the component, you use props. So you allow this component to be modified from outside. So you was writing this code anyway. So you were making your components dynamically anyway. So you was creating all these best practices of not hard code the text and put the props from outside. So there is no difference here on how you build it. So what you do here, you just create. I have put the underline. So you have an image. On the SRC, you're getting this CDN link from outside as a prop. You have the props company name, and you take this title from outside of the component. And then you just export the component as you already do. So there is no change here. This is proper React component. So after you create the React component, you just have to register it. in a file called cms-driven.js. So you just import it and then export it to the module. So you make it available for the CMS to use it. Then you have to go to the cms-driven.io and you have to add a new UI component there. So you are going to use the same name as the component name. As you can see here, made with love. It's the same name with here. It's the same name we put it here on the key. Made with love. So you just you name your component, and then you add the props. So you add the props one by one. You add company name, IMG, and alt. As you see, this matches exactly the names of the props here. So you make CMS driver aware about your intentions, about that this component needs these props. And then you can see on the right side how it looks like as an example. What are the possible values that this component could take? It could take a string. Initially, company name is a string. IMG is a CDN link as a string again. And an alt is still a string. You can put more types. You can put booleans here. You can put integers, rich editors. There are more options. And then what you have to do, you have to create a page on the CMS-driven side. So you forget about these page components. So you don't have to write any more page components. This is on the past. So you can just create a new URL page, localhost 3000 / React.js or / George, and any name. And you put your title. The title is the title of the page. You put meta descriptions, very easy to understand, meta keywords with comma separated. And then you can say things like, I want my page to be indexed by Google search engines, or I want them to be I want the search engines to follow the links within the page. And you can choose if you want to, if your page is a dashboard and it's like a private, you don't want to enable these actions. So by saving this now on the screen, it's going to create a new page behind the hood. So you don't have to do anything on this manually. And then you can just import by clicking this button, import UI component. You get a list of the components. You click one of them and you put them one after the other as a block element components. And this is like the made with love will be like the block element. And paragraph will be another block element, as we talked before about BEM. If you click now on the first component, you will get something like this automatically generated for you. So you are going to get a form generated with all the props. For example, the company name was a string. It's going to automatically create an input for you. So you don't have to put a JSON file there. The IMG is going to allow you to upload an image to a CDN on Google Cloud. And the alt is going to allow you to put a string there. So all these props are going to automatically feed the React component, and it's going to place this React component with these properties into a page that we created before here, this React.js page. So this React.js page will have the made with love component. This page React.js will have the made with love component as the first component, paragraphs as a second block element component, and features as the third one. And the made with love component is going to have these texts printed to, it's going to look like this. So I just mark it around so you can see where it is the component. So the first component block element will be made with love. The second will be paragraphs, and you can just reorder them. So if you see here, you can just click on the right and just reorder the components up and down. You can delete one of them if you want dynamically without any code changes. And when you are ready and you have tested everything to your local environment, you can just click go to production, and this will send everything to production without any code change. You don't involve at all a GitHub. You have done no code change essentially. What you have done is just you change the props. That's why you don't want even to test it, because you have already tested to work in a predictable way in the first place, in a dynamic way. You have just tested, you have created your unit tests, integration tests, and end-to-end tests already. What you only change are the content of the props. It's not the behavior. So there are like different steps here. Like you first, okay, what you say, George, now is you just building a UI component library that you can reuse. You have built you maintain a live documentation. You can drag and drop these components to a page dynamically from this live documentation, and at the same time you can add the same page itself dynamically. So how cool is this? And yes, and now it takes me to the live coding challenge that I want to put you guys, and I want to see how you guys doing after the Q&A. So I'm going to explain what is the coding challenge, and then I'm going to go to a Q&A to answer questions. And when you guys finish with this, you can join us, and we take it from there if you have any questions, and see how you progress with these ones. So I would like from you guys to build a dynamic page called /coding/challenge. The page title I want to be, you can put anything you want on the page title. I just say coding challenge at the moment. You can put a meta description, which is, this is a test coding challenge. You can put a meta description. This is for search engines to find your website. It can be coding/challenge/seams driven. And you can put the meta robots settings to index and follow. So this means that search engines have to follow the website and index the website and follow the links within the website. And then you can create a new UI component. I want you to call it one paragraph, let's say. And this is going to only have a title, a paragraph, and maybe if you have more time on this, you can put an image also. And all of them I want to be handled from outside. So I want this UI component to be dynamically, the content I want to come from outside. I want to come from the CMS. I want you to register this UI component after you build it. As we said, this is a UI component that you can just, it's not very, it's nothing. If you know how to build a UI component, you can build it. It's nothing to do with the CMS. Then you have to register it. This is the extra step. You have just to register this component. And you can do this first of all, on the cms-driven.js, which belongs on the root folder of the boilerplate. And then you have to register it online. You then can import the one paragraph component to the page that initially I asked you to build, the /coding challenge page. And then you can add another one, so you can reuse now the same component. So you can have one paragraph and another paragraph, but with a different content this time. So you will reuse the same component first and then second, but with a different title. And just to help you out, guys, I have put this on the right side. I have put some CSS because you will not have like all the time right now to build a CSS and everything. So I have some ready-made CSS, so you can use this for your UI component. And you can always have a look and see the other components that exist already on the folder, and just see how it's done and just repeat it. That it is at the moment as the talk. After we finish all of this, if anybody wants to be part of my focus group later on, you can be in touch with me on these links. Because I create a focus group, I give it for free. I'm just going to get some feedback and improve it and pivot to see how you developers want to this product to be built, because this can be potentially a good tool for is the next step between having a storybook, which is just a documentation, and having a CMS, which is nowadays is only headless CMS out there, and there is no this gap in between how you can just build a UI component library and you can just drag and drop these components into a dynamically made page. So ideally, we want as developers to build a UI component library, and we want to just test our components, build them in a good way, focusing on how to create like a documentation about them, be proud of them, be proud of creating this UI component library, and then leave the page generation to somebody else. They can just create a new page, they can put them inside, they can play with them. It's all good. You don't have to anymore to create page components. You don't want to create page components. You don't want to create routing anymore for especially for marketing and landing pages. That's it. Thank you for your time. Let's now go to the QA, right?
Yay, thank you, George. That was amazing. Very nice presentation. I can see people are really excited about that. They are asking questions and we switched actually to the YouTube stream. I hope everyone can see that. I shared the URL. Then Geekle, our tech guys from Geekle will also share it in all the chats and comments. George, you can take a few minutes break just to refresh, take some water. Meanwhile, I'm starting the Q&A room now, so please everyone join in a few minutes. I'll warm you up, then George will join and start answering your questions. Thank you, George, again. Have a nice day. See you on the Q&A.
Thank you a lot.
Thank you.
So yeah, we are basically ready for the next speaker. I'm not sure if you need some time to warm up, but still, okay. Mathieu, show yourself, please. Mathieu. So we are going to talk basically about, yay, hello, you're here. Switch on your micro.
Yay.
Yeah, okay, now it's good. So great, how are you doing?
Good, I'm good, thank you. Yeah.
That's nice.
And you?
Okay. Me too. Thanks for asking. So maybe tell us something about yourself, just a couple of words, and we may start.
Okay. I will go through this in the beginning of the talk, but I'm French actually. Came to work in Norway 15 years ago. Initially for Opera Software, the web browser company. And 3-4 years ago, I joined Microsoft to work on try new challenges and new opportunities. I think it's really good company to work for. I was amazingly surprised.
So thank you. I wish you luck, and you may start.
Yeah. Okay, let's try to share my screen.
Yeah, exactly.
Can you see the slide?
Yes, it works. Everything is fine. So you may start.
Let's try to go full screen. So you just see the slides. Perfect. All right. Well, thanks, Holger, for a nice introduction and for having me today. Just in case, for the people who may watch the talk later, my name is Mathieu Henri, and you can find me online as Visio1. My computer background is split in three aspects. When I was 6-7 years old, I joined the local code club at my hometown, and I really liked how the teachers introduced a new concept or a new primitive, like how to draw text or line every week, and they ask us to be creative with that, to create something. And just writing a few lines of code and seeing some pixels on the screen was really magical for me when I was just a few years old. And that really got me hooked to computers and programming. I try to bring back this magic in the code club that I created 2 years ago at the school of my daughter, and like introducing kids to programming via creative coding. As an extension of creative coding on the code club that I joined as a child, I got into the demo scene about 30 years ago. And the demo scene is a movement that pushes the technical and artistic limits of pretty much any platform. It's very much creative coding, but that goes even beyond, like really tries to dig into technical aspects as well. So it's really, really fun way to learn. And nowadays, I am software engineer at Microsoft, where I build software for millions of people. My team works on what we call the mid-guard applications. They are high-value components, all related to people experience, such as profile card, that shows some information about a person when you see a name or photo, the contact editor, photo picker, profile picker when you add mention someone, and some components in Microsoft Search. All these mid-guard applications are used in 6 platforms on the web, from i11 to Android, iOS, Mac, Win32, and Universal Windows platform. They are used in over 40, close to 50 Microsoft 365 applications, such as Outlook, Word, Excel, PowerPoint, OneDrive, SharePoint, Office.com, Teams, and so on and so forth. We work on a big mono repository with about 300 packages. We are around 200 active contributors at the moment. And we have in the orders of hundreds to 200 million users. So you can see some of the components on the right-hand side, and they are also used on the Microsoft Bing. If you connect your account to your company, and you can search for company-wide documents and people. And this is a big mono repository where everything that can be reused is reused, and we use TypeScript.
Matthew, I'm
Yes.
really sorry to interrupt you, but we're seeing your script, kind of. So can you a bit shut it down? Because we didn't. Yeah, now it's okay. Now it's okay.
How that is. Right.
Because we haven't seen your presentation.
No.
Yeah, and now it's okay. Now it's okay.
But yeah, sure.
Yeah, it's okay. So you may continue.
And if I do this?
If it's like this, so we see a black box.
Okay, that's a bit annoying. All right, let's continue like this.
Yeah, okay, thank you.
But didn't work that way in the test yesterday. Anyways, so Midgard is really a big set of applications used across many pages and many applications of Microsoft 365. And we use TypeScript for most of the code. And about 70% of the code is reused across all platforms. So that gives us a really, really big surface and many challenges and opportunities to break things. Right. So it's clear to all of us today that we live in extraordinary times. With the pandemic going on, we see more people using online tools to work from home. And it's especially important to test and maintain our software. So today, I would like to talk about end-to-end testing, a world of web, mobile, and desktop applications. I would like to explain some of the things we learned, how we improved some of the techniques, and some of the challenges and things we have ahead of us. So the plan for today is to talk about software testing in general, then component testing, which we have seen a bit with Charlie and George before. Then we'll go to end-to-end testing and visual regression testing. So starting with software testing, if you write and ship any piece of software, you have to write some form of test to ensure that the code you write is conform and meets the quality requirements, and it does what it's supposed to do. So looking into software testing, you will encounter the test pyramid, which is really the foundation of testing. The basic idea is that the amount of test is the inverse of the abstraction level. So at the base, you have unit tests, which are really isolated and really fast to run. Then you go into service tests, which are also called integration tests, but test the interface between different services and APIs. which need a bit more integration and are a bit slower to run. And finally, you have UI tests, which require a lot more integration and are obviously slower to run. For Midgard, we do not do service tests or integration tests so much because the developers of these services or that we integrate with, they really test on their side. And we write a lot more end-to-end test or UI test, which also covers all the layers of abstraction. So that's how we go. Another notion which is really important is the code coverage, which is related to the amount of code that your test covers. So some teams try to aim for 90 or 100 code coverage, but that is not always possible. If you write TypeScript, because of the strong typing, you might have to write some never clauses, which are by definition never reachable. And then you cannot get 90 or 100% code coverage. So you need to write different types of tests to get full 100% coverage. And it gets really tricky to get your full code coverage or a good picture of code coverage when you combine different types of tests. So for Midgard, we do not chase a really high percentage of code coverage. We just try to cover more than the happy paths to make sure that we test bad scenarios. But also we use the code coverage more to guide the type of test that we write, that we should write, where we have some gaps. And so that's really a guideline how you should use code coverage. Overall, our testing strategy for Midgard goes this way. We have a foundation of static test, which is using TypeScript and strong typing. We use ESLint and Prettier to make sure that the code is statically correct and that we have strong typing everywhere. And that gives us like a very strong foundation as we write the code. Then we have unit tests as usual. And then we move on to more visual things like visual regression tests like component test and end-to-end tests that really test full scenarios. Eventually, because the Midgard applications are used in many applications, and with deep integration into, say, Outlook, to use the Outlook functionality to send a mail or to start conversation with someone, and if you're in Office, to share documents or these kind of things, we need to do some manual tests to validate a bit. At this point, we roll out the code to the outside world, and we do that gradually. And we monitor and have real-time alerts on any of our telemetry, which gives us performance alerts or reliability alerts in real time. And we can act on that and roll back very quick if there's any problem. So we move on to a second aspect, which is component testing, which we have seen a bit with Charlie and George, previous speakers today. And this is about validating your components. The Midgard applications are built using TypeScript and React. And so we build UI components and we combine them together and with a lot of logic and data fetching. So we need to test these components. You heard about Storybook in the previous talk, and we use it to validate the components. It's really the perfect tool to test your components in isolation, and it's UI framework agnostic. It works with anything, usually. And the good thing also with Storybook is that there are a bunch of add-ons where you can run, for instance, accessibility tests, which are extremely useful. Using the component stories format from Storybook, the tests look a bit like this. Here are two stories where you export a test called button and two functional components that show static props. A text button which just says hello and an emoji button that has a bunch of emojis. The nice thing about the component stories format is that it's really simple and very versatile. You can use it in different ways. Here is an example of component tests from Midgard, where we test the organization panel. And in this case, I highlighted the code for the ghost organization entry, which just renders static setup probes. There are some limitations. The Midgar applications, they do not live in isolation. They really are embedded in many applications across multiple platforms. And also there is quite some overhead to Storybook itself. And Storybook works very well for web. It works okay for native, but it's not there for Windows and Mac. So we're working on something. How we test the Midgar component is that we use Storybook for the dev loop and CI. And we are working on leveraging the component stories format to write a simple component test that would very quickly render the components, and then we can add all these extra features like accessibility test and performance testing, which you can do with Storybook. Just that in a more lightweight version. And this simple render would be extremely easy to develop across platforms. That's another big advantage, which is not possible with Storybook at the moment. Then we move on to end-to-end test, which is about testing complete user scenarios from end to end, like really from the full spectrum of your application lifecycle. So we do that to test many user scenarios, but also with visual and performance regression testing in mind. So first, you need a way to automate your task, and there are different ways on different platforms. What we chose for Midgar is, after testing different toolings, was to use Appium on Mac. Appium works on more platforms, but that was really the best fit there. On Android, we use Espresso, which is specific to Android, and it's really fast and reliable. And the same can be said for XE UI tests for iOS. On Windows and Universal Web Platform, we use WinAppDriver, which is really the best fit for all Windows platforms. And on the web, we use Playwright, which is a Node library written in TypeScript to test in Chromium, WebKit, and Firefox, and it works in all platforms, Windows, Mac, and Linux, and on CI. It's really good fit. Some other tools that we looked at were Selenium and BrowserStack, which have been there forever. They work with all browsers, but the setup and the developer experience is really not great. Another one we also looked at is Cypress, where the developer experience for web testing is amazing, but we need to cover more browsers than what they support at the moment. So now that we have a way to automate our test, we need to run them, and there are different ways to do it. You can import the test code, like any library or any import in your code, or you can inject it using the task runner. You can do that using a live application or a test application. And again, you can also do that with live data or mock data. For native, they typically target a single piece of code, target a single application on a single platform. So things are really more isolated, and that allows them to really test in a test application, import the test, and also use mock data or even replay the data from a network calls. So it's really isolated, and it's really cheap and really fast. For the web, our test surface is much bigger. The same code that we write is used in all the browsers, in Outlook, in Office.com, everywhere. So our testing surface is much bigger. Therefore, we have to test against the live applications. And also because the type of data that we surface in the different applications is different, we need to use live data. Of course, we use test accounts, but that's just makes sense. You use test accounts as well. So we test in prod with live applications, test accounts, and we import the test, or we can also inject them. We do both. And then you need a test framework. For native, because the tests are really more platform specific, I will not go too much into details, but for the web, we need to define and run the test. Typically, this looks like that, where you have an ID that represents your application, and then a list of scenarios with a URL, a label for this scenario, some CSS selectors to show and hide elements, Then if you want to get some elements out of the way, if you have some widgets like a map or ads, banners, or so on, then you have some selectors that would say how to interact with page, click a button, enter some text in the title or in a search box and so on. And then you have some selectors that tells you on what to assert or what to screenshot, in this case, header and content. So it's really straightforward definition of a test, but there are some clear limitations with that. It's really designed more like a unit test. And one big drawback that we see is that for every test, there is a single interaction before taking the screenshot and closing the page and reopening the page again and moving on to the next test. Really, one test definition means open a page, do something, close the page, and then move on to the next test. For our use case, what we see is that the mid-guard applications are embedded in many websites, and these websites they can take a while, or they can take several seconds to boot up and to reach a state where you can actually interact or access a mid-guard application. And we cannot wait 5, 10, 20 seconds just for the application to boot up for every single test. So we created our mid-guard end-to-end test framework, which is designed to run end-to-end tests with multiple interactions and screenshots. The goal is really to open the page once and run all the tests you can, all the tests that you need, take all the screenshots that you need, and then close the page. That way you really make the best use of your sessions. So how it works is that the test framework opens the host application, say Outlook, Office.com, Bing, with the build that you want to test and the feature flags that you want to test. Then it imports the test code or inject it via the test runner. It tests many end-to-end scenarios, really full scenarios, request many screenshots, take some performance or CSS measurements if you need, and eventually close the page. And then move on to the next application where you test again the same build, maybe with different feature flags and so on. And the test definition looks a bit like this. So you just have the ID or the name of the test, in this case Office.com, the URL where you want to open this application, with some query string arguments about the feature flags that you want to enable for this test, which build you want to test, and then you can define the actual runtime test file and some dependencies. So much simpler. And then it is the responsibility of the test themselves to test and to handle the workload. The test code looks a bit like this. We just have a library mid-guard test automation that typically waits for the mid-guard application to be ready on the page. It might need to click somewhere on the page to activate something, say to open an email, so that then you see the name of a person, and then you can access or interact with this person control. And then we test the card for different personas and complete. The tests are really high level, but they test many scenarios and they go really, really deep. The limitation we see with this is that we still cannot test the host app integration, but that's because the host app integration is really depends from one host application to another, from Outlook, Office.com, Bing.com, you name it, SharePoint, OneDrive. The way that they handle different actions, like open a mail, send an email, start chatting, opening a document is really different, and it's not always possible to test that. If they open a native application, you do not know if this operation succeeded from the JavaScript side. So the end-to-end testing pipeline looks like this. We can run it from command line and parts of it from CI. The tests ideally are part of a package, and that allows them that when you write a code change, the dependency graph will collect the test to run as part of a dependency graph of code that you did change in your PR, and then the test run against the tip of master. The screenshots become build artifacts, and then we can easily dig them and report in the pull request. And the result of that is that all our end-to-end tests across platforms, they really test the applications really deep. Right? They really test hundreds of thousands of scenarios, which is perfect. It's really what we want. And we also end up with many screenshots because we also want to make sure that across the different browsers, the style does not regress because we do not control the whole stack. Like a different application that consumes a mega application inject global JavaScript, global style sheets that interact with our components in ways that sometimes are breaking. So we really need to do these screenshots to see what happens in the live websites. And that brings us to the visual regression testing. So what we saw before about the end-to-end testing is that we have platform-specific ways to run the test that really covers many scenarios and produce screenshots. And so this part is platform-specific. Now, the end result is that we get many screenshots, and it doesn't matter how they are produced. We can diff them. We can compare the screenshots in a single manner so that we can really bring some values for all the platforms. The tool that we use initially to compare the screenshots is Pixel Match by Mapbox. It is very small, very simple, very fast JavaScript library to compare images pixel by pixel. And it has been made especially popular by a blog post about how American Express does visual regression testing with Jest and React. And the way it works is that Pixel Match looks at the pixel buffer of the image at the 8-bit integers buffer and compares the red, green, and blue values. So let's go. We have a very simple example here, and let's go through it. So it looks at first the alpha component of the baseline at the top and candidate at the bottom. And if they are the same, fine. Looks at the red component, same, fine. Look at the green, same, fine. Look at the blue, same, fine. And then, okay, that was the same. So let's output a washed out version of the pixel. And we do the alpha, the red, the green, the blue component. Now let's move on to the next pixel. We compare the alpha, it's the same. The red, that one's different. Green, different as well. The blue is different as well. Okay, so let's output the alpha of a highlight pixel with full alpha, full red, and no green, no blue. And we move on to the next pixel. Compare the alpha, the red, the green, the blue, output a washed out version of it, and so on and so on. So the nice thing is that then if we compare a baseline screenshot against what we had, suddenly we get these type of things. We get a washed out view of our component of our app with in red really an highlight of what changed. So it's a huge step forward. Here you really see what that something changed. The problem is that you cannot tell what actually changed in which way. If I see this, I cannot say if I would accept or reject a pull request. So this is not really actionable. Also, it's not so fast. You saw that there were many operations, and it's really difficult to read, and we completely lost context. You could display the baseline and candidate screenshots in a pull request, but these screenshots they might be stored behind authentication, and then it gets really complicated to show 3 screenshots from different storage to anyone in mail even. It gets really complicated. So we built a screenshot diff package, which is extremely fast, and the goal is to really to be extremely fast and give actionable screenshots. So it gives a lot of context, and you can think of it as a Git diff, but at the pixel level. Like when you're looking at the pull request, but imagine that for pixels. The way it works to be extremely fast is that instead of looking at the colors byte by byte, it looks at them as 32 bits integers. So first, we look at 1 pixel, 32 bits integer, the whole RGBA value for baseline candidate. And if it's the same, good, we output a wash validation right away, like the 32 bits. If we see that they are different, like at the next pixel, then we drill down to look at the individual components. And then we output right away, boom, a 32-bit integer that highlight the difference and so on, just looking at 32-bit integer. So we cut down the number of comparisons by 4, and there are more optimizations, and it also works across multiple cores. What we get now is, well, before we only had this thing in the middle, but just highlight that something changed. Now, if you look just at the right-hand side, you see your current change, and in red, you see a ghost of the pixels that basically were removed. And the same on the left-hand side, you see what was the state before, and in green, a ghost of what has been added. So if you just look at the middle, it's hard to say if you will accept or reject change. If you look at both sides, then it's really clear that we just changed the string and the change is acceptable. If we go back to the first example, where we only had the thing in the middle, it was impossible to say what to do with a change. But now, if we look at the change from my pull request, I see what this application looks like, and in red I have a ghost of what it was before. And it's really clear here that basically we only change the typography and margins. And that was the intent of the change. So we can just accept it and move on with our merge pull request. So one thing is that the midgun applications are really third-party components. They really behave that way. They live inside different host applications, and we can still see these host applications in all the screenshots. Like if you open Outlook and then you click on someone, you would see a profile card of this person's pop-up, but Outlook is still behind with everything. So for us, that is noise, and we need to normalize that. So at the beginning of the test, our test library inject some CSS rules to normalize a bit the page. And one of the key things is that we hide everything from the body that is not our components. We avoid custom scroll bars. One thing which is actually pretty important to avoid the noise is to put the caret, the cursor that typically blinks in text box or input, to transparent, so you don't get noise of this blinking cursor. We also collapse in time the transitions and animations so that all transitions and animations are really instant and you don't get screenshot at a random point in time. Also, one really nifty thing is that web browsers know how to render images. Like they have rendered images for 25 years now. So we don't need to test that. So we just apply a filter with a brightness of 0 on all images. And that way we black out the images. We don't need to get noise for like half pixel precision or these kind of things. And that gives something like this now. You see the card, and images that are really images are blacked out. We still get the ghost in green and red on both sides. We also added, as we use this library, a low resolution highlight that really shows where are small differences in pixels that would be difficult to find. And we also optimized this library a lot, really, to the point that on commodity hardware, we can diff over 1,000 screenshots per minute, while that was completely out of reach for pixel match for our use case. So if you want really wicked fast side-by-side screenshot diffing, I recommend that you npm install screenshot diff. You can try it, tell me what doesn't work for you, and I will try to help you and make it suit your use case. In summary, how we test midguard is through a set of static tests using TypeScript, ESLint, and Prettier at dev time to make sure that all the code you write is statically correct and strongly typed. We have unit tests that not only cover the happy path. We run several, many end-to-end tests and visual regression tests manually from command line and from CI against the tip of master to test our components. At the moment, mainly on web, but we also have some tests for platforms. We eventually, when we validate a bit, we do a bit of manual testing, mainly for the host app integration, which are really depending on which application consumes our components. And then when the code is out and released to production, which we do gradually, we keep monitoring and use real-time alerting to act immediately when there is any regression. With that, thank you very much for having me. You can find me on ASP.01, and with your help, I would like to improve the state of visual regression testing for everyone. Thank you.
So thanks a lot. I hope it was informative, and I hope we didn't have any issues with our connection. Yes, actually we did. So yeah, now I'm going to send the link to the chat with a QA room with Mathieu. So you're welcome if you want to ask him any questions. And yeah, I suppose that before we are going to start the Node.js section, we are going to have a short break, okay? I suppose it's going to be like 10 minutes or even more. So once again, stay tuned and don't go anywhere. Maybe you can go and have some lunch. But still, in 10 or 15 or even 20 minutes, we are going to be back, okay? And yeah, right now I'm going to send the link to the chat. And also I'm going to send a link for you, Mathieu. Oh, now it's there, okay.
Everyone. Hi, everyone. Welcome back. So we are ready to go with the next session. It will be, this topic is called Callbacks to Async Await in Node.js and Build Your Own Promise. Our speaker is Tamar Twena-Stern from XM Cyber. Welcome, Tamar, to the stage. How are you?
I'm great. I'm really excited to be here. Actually, this is my first online conference. I've done a lot of conferences which are not online.
Yeah.
This is my first online conference, so I'm very excited of the occasion.
Good luck then. So I'll be here. I will keep an eye to the audience. We can have some chats here, and on our YouTube channel, I'll bring you some reactions from the audience from time to time. And just keep going. I'm here with you all the time. Good luck.
Thank you. So I will start now, and I am sharing my screen.
Brilliant. Yeah, I can see your screen.
Okay, everyone can see?
Yep, the screen
okay.
is going to the screen.
So hi, everybody. And as I said, I'm very, very excited to be here. And my name is Tamar Twena-Stern, and welcome to my session. So I'm writing in Node.js for quite some time, for several years. And I remember very well the callbacks period. So we are going to talk about the transformation of the code from callbacks to async await, and about promises and what is a promise. And at the end, we're gonna show a small implementation of a promise. We're gonna do some performance measurements in between. But, let me start with telling a little bit about myself. My name is Tamar Twena-Stern. I'm a software engineer, and I manage a large team, and I'm an architect. And currently, I lead the backend in a company called XM Cyber. We are a startup in the cybersecurity field, and we are really cool. We're simulating a hacker, and we're hacking to your computers. We're doing a defense by offense. And another thing that I can say about myself is I was a CTO of a startup of my own. And my passion about Node.js has started when I founded my own startup, and I have wrote the entire backend from scratch in Node.js. And then I started to get really deep into that technology. And you can all follow me on Twitter. So another thing some stuff that I would like to tell about myself. So I have 3 kids, and the smaller one is 1 year and 3 months old. I'm a community leader in JavaScript Israel, and this is the largest JavaScript meetups lineups that we have in Israel. And I'm also a professional violin player, and I'm a code writer, of course. And let's just start to get into business, and let's talk about what is blocking IO and what is non-blocking IO. And that would fit really into our conversation about why callbacks are used in JavaScript. So in most languages like Java, C#, Python, so in those languages, what's happening is that when we're doing an IO operation, such as a database query, such as an HTTP request, so we are waiting for the result. And that makes a lot of sense, because usually wants to do something with the result in your code. But in that approach, in order to handle a lot of requests, we need to open a lot of threads, and each thread is coming with an overhead of memory, of CPU, of engines, and that's really in high level. And also, a lot of times you also open background threads. So in that case, when the system is stressed and you have a lot of work, So you have a lot of like context switching to do. And the context switching starts to take a lot of your CPU time. I don't know who of you worked with thread, but it's usually that like you add a lot of threads, and at some point, you know, you're working with 100 threads, and then you're working with 200, but you see that the performance are not improving, and there's even a degradation. So that is the reason for that. So as I said, so this is the problem. So when the system is stressed, actually the system is doing a lot of context switching instead of doing actual work. So Node.js is working in non-blocking I/O. Non-blocking I/O means that while you're waiting for an I/O operation, which is heavier than regular memory operations, you can do other stuff. And for that, the mechanism of event loop was designed. Event loop was in JavaScript in the browser from the first days of JavaScript. And then it entered the architecture of Node.js. So really in high level, when a new request is coming to your Node.js server and a callback is being registered, and after the registration of that callback, the event loop starts to execute all those callbacks. And when it has I/O operation, it offloads it to another component called the worker thread pool. When it's doing that, so after that, when the event loop is actually, when the operation is over, the event loop is getting a signal that the operation was over. And in that case, the logic that has to be executed after the callback is finished is being executed. And in that case, you're doing much less context switching, but that takes us to a pattern called asynchronous programming. So since synchronous operations are blocking the event loop, the JavaScript has implemented callbacks since the beginning. So callbacks in JavaScript are first-class citizens, and there was no return value, only callbacks in the earliest days of JavaScript to support asynchronous programming and non-blocking I/O. And this is how asynchronous code looks like. It looks like, let's say here we have a model and we're doing save. And then if there's an error, we're returning an error. Otherwise, we're doing success. But you're seeing this code, everything is callbacks. So now we're asking the question, why callback programming is so bad? Why is it so bad? Well, I would like to introduce you this. That is called the pyramid of doom. And that is like callback from callbacks programming hardcore. And you see that from those callbacks, it is really, really hard to read the code at the end. You don't really know what is the flow. It is really, really hard to understand the flow. So that's what this callback programming has created. Another thing which is interesting here, and I don't know if interesting, but it's easy to miss, is error handling. You're seeing here, well, if there's an error, we are returning the callback with an error. So the caller would know that there was an error. But here, there is another error that's hiding here in the JSON parse. Okay, JSON parse can also throw an error. And that can be a problem, and that code would just crash and crash with an error, and that code was not written well. So here is what we had to do here with the JSON parse, and that is a way that callbacks programming is making us make it easy to miss those errors and handle them. And another thing which is really, really hard to implement here is to implement control flows. I mean, if we want to do something serial, meaning to do one action after another and make sure that nothing would get in between, it's really, really hard to implement it with callbacks. And also parallel programming is really, really hard. And these are capabilities for flows that we need in our everyday programming. These are very, very important. And after all of that, promises have come into the JavaScript and into the JavaScript world and entered into Node.js. And that was entered actually to make life of the developers easier and to make the code look readable and to reduce the nesting level. So what is a promise? A promise is actually a proxy for a value that we don't know yet. I mean, when we execute a promise, we don't know what the value would be. So I guess most of you are writing with async await right now, but in promises programming, you can register a handler to a success operation. You can register a handler to failure operation. And so that is what you're doing. And a promise is an object that it has states. Okay, a promise starts in a pending state. And then after it's being executed, it can receive one of these two states. It can be fulfilled or rejected. Okay, so these two states, fulfilled or rejected, are the final state of a promise. It's just came from, like, I think the manner of speaking of the promise is kept or the promise is broken. But yeah, if it's fulfilled, if everything is good, then there is a value that we return. And if it's rejected, then usually we are returning an error. So the promise code here looks much, much better and much less nested than the callbacks code. If we were talking about the pyramid of doom, then right now with promises, the code looks much, much, much better. And we reduce the level of nesting to only one level, which makes the code much more readable and much more easy to write. So I would like to talk about promise libraries. So we have a promise, we have native promises functionality in ES6. And there is Bluebird also, which adding a lot of extra functionalities that usually ES6 promises doesn't add. But it adds a lot of capabilities that the ES6 native promises doesn't give you yet. So after we spoke about that, I would like to measure some performance of promises, and I would like to do a little bit of trying to compare between the Bluebird promises and the native promises. So why am I doing that? Why I would like to compare? I'd like to tell you some history, because in Node 7 and Node 8 versions, so Bluebird promises were much, much faster than the native promises. Okay, so I got like a lot of time differences that were like twice faster. Like Bluebird was twice faster. But I would like us to measure this, and I've lectured, like, I think in 2 years in a conference, and I've shown that in Node 8, well, Bluebird is much, much faster, but things have become a little bit different now. So I would like to open my VS Code. Hey, here it is. And I would like to show you some code. And I would like to do it in, well, let's see. What's my current version? So my current version is 10. Okay, and I have here 2 scripts actually. I will just open them one next to another, and we'll just look at them. So this script is working with Bluebird promises, and what we're doing is we are resolving, I think, around 1 million promises. And the executed code that the promise is doing is something really simple, which would not affect performance. And then this used the native promise. Okay, the native promise of the language. And okay, so I hope that everybody is seeing my console. But here we're doing the same task. We're running 1 million of promises. And we're going to see how much it's going to take to do the resolve here. So I really hope everybody could see my terminal well. Here, I'll just do it in VS Code. And let's do Node Bluebird. Okay, so we've got around 1 second. And let's do Node native. And we're going to see what we're going to get. Okay, so I have to tell you that in Node 8, the time difference was like twice. It was like 2 seconds vs a second, and Bluebird was a clear winner. But in Node 10, we have a time difference of 200 milliseconds, which means that native promises are much, much faster. I mean, I know that the Node core team are doing a lot of work in that area to make native promises much faster. And then I would like to do, I hope that all of you are familiar with NVM. So I would like to switch version with my NVM, and I would like to do NVM use. NVM is a tool that helps you work with multiple node versions at the same time in your computer. So I would like to do NVM use this version 12. And it's interesting to see what was the improvements in version 12. So right now we're in version 12, and let's do right now Node Bluebird. Okay, and then we'll do Node native. Okay, so this is interesting. This is Bluebird and native in version 12 of Node is quite the same, and native is even winning in performance-wise. All right, so Bluebird is 1.16 seconds, and my test in native in version 12 is 1.1 seconds, which is quite an improvement. So I would like to say that when I lectured about performance in previous sessions, I said use Bluebird, but you know, the performance work of the Node team like really increasing. So right now I'm saying if you're choosing a library, go with native promises. Well, because that is like I think that the promise library that would be most invested. And you know, if they're beating Bluebird in performance, I guess that the Node core team would like beat them in the future with functionality and would add more functionality. So that is really, really good to know. And if you would combine Bluebird, it might be that it would be hard for you to get rid of it. Another thing that I would like to say that I don't know if you're familiar with async hooks, but I've done this test with async hooks, and with async hooks, the native promises, I mean, with async hooks enabled, the native promises are much slower than Bluebird. So that is another consideration. But right now, if you don't have async hooks enabled in your system, I really prefer to go to the native promises and not to Bluebird. So that's what I had to tell you about async await, about promises. And now we're going to go into our next phase, which is async await. So what is async await? An async await is a syntactic sugar, I have to say, that entered our language in ES7. And it is only gives you the ability to write promises in a more readable way, as an async function is just a wrapping of a promise for a function. An async function returning a promise, and within a wait, you are waiting. For the promise. So that makes the code look really clean and concise, but behind the scenes, although it looks like you're writing the synchronous code, behind the scenes, everything is asynchronous, as we saw in the beginning. Everything is asynchronous. Everything is working with asynchronous operations. That is an async await code. Async await code, as you can see, is much, much cleaner. It's much easier to understand. It looks like a code that you write in Java. So how that improved the situation? First of all, there's no nesting right now. We don't need to write with the nesting, and we don't need to register any anonymous callbacks. And we're not creating a variable of all those variables that we don't really need and all of this stuff. So that is cool. The error handling is much cleaner. Look at that example that we've seen in the beginning of the lecture with the async await. Right now, we're handling the error in one place, one unified place. There's no like hybrid handling. And that is very, very good. We don't need to transfer intermediate values. And that is also very good, makes the programming really, really simple. And executing stuff in parallel has become much, 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 this has become much easier with Promise All. So that really improved our life as developers. So I would like to just say my opinion about promises. A lot of people see in promises syntactic sugar, and I don't see them syntactic sugar. I don't think that promises give syntactic sugar. That's my opinion. Async await is pure syntactic sugar. In contrary to promises. Async await is just a better syntax for writing promises, but promises gives another functionality. So we spoke about the object being the state of the object. We spoke about that it starts with pending and then it gets a resolve or rejected. And it's actually helped me to save the values. So I have succeeded to implement a cache initialization with promises. And that helped me, like that functionality of promises helped me in first initialization. So if you're implementing a memory cache for some reason, and you want to make sure that a value would not be initialized twice, then use promises and save promises. So that would help you a lot. Right now, I would like to speak about another problem, which is created by the fact that the code is very, very, very concise and clean. I mean, the code with promises is very neat, no nesting levels, and it is misleading because we are actually thinking that the code that we are working on is actually a synchronous code, okay? And when we're thinking that this is a synchronous code, we don't get the time to understand the architecture and understand that we're working with asynchronous operations and with non-blocking I/O, okay? So we can miss the biggest advantages of Node.js, which is non-blocking I/O. What does that mean? So In Node.js, we are getting an advantage if we're running stuff in parallel, okay? But if we're running it like really with async await, and we're doing one action after another, we're executing one operation after another, then we're creating patterns of serial code that in real life does not perform really, really well. What do I mean? Okay, so look at this code. This is like, that's called actually sequential IO. So let's assume that get users is doing DB query to users, and get categories is doing DB query to categories. And then we're returning both of them. But you can see that users and categories are not dependent at all with one another, okay? So we can run both of them in parallel, and we can actually use promise all. And with promise all, we can run them in parallel and get better performance. So I've prepared a really small demo for you, so you would actually see that you know, that can help you save some time. So I would go back into my VS Code, and I would just open the second demo that I have prepared. So that is the demo. Now let's go over it real quick. All right, so let's see what is going on here. So actually that is an Express server, really simple Express server. I hope that everybody here is familiar with Express, and I don't need to get into that library and explain about it. And I have here too, that is actually written in MVC pattern. Which I have a model which is maps to a Mongo schema, and I have a person, and I have two entities here. I have an entity of a person and an entity of a pet. Okay, so that is the mongoose model of the person, and that is the controller, sorry, that I have. And that controller, I'm creating a person, and I'm just saving it, and I'm giving it my name. And here I have another thing, and that is a pet. And let's say that the pet has a name, and also that is the model of the pet mapped to mongoose. And this is a controller, and here I'm creating dogs. And then let's go to the server itself. Cool. So let's go to the server itself. So that server is actually exposing, wow, that's embarrassing. So that's actually exposing one route with a slash, and that is the parallel server. Here I'm working with promise all, and I'm creating, I think, 8 entities in parallel. And here I am working with a serial code, and I'm creating 8 entities, one after another with a wait. I'm like waiting for every entity to be created. And that is, as you can see, those calls are not related to one another, and we can work with them. So I would just hope that all of you have enjoyed the code. So I would go to my terminal, and what is this?
Tamar?
So yes.
Yeah, I'm here to remind you that we have 5 more minutes.
Oh, we have 5 more minutes.
Yeah, and then we'll be moving to the Q&A session. I shared already the URL.
Okay.
Is that clear?
So I would just like to really show you the code. We would go into here, and then we would do no. Just a sec. Yeah. Then we would run this. Okay, so that thing is working. And now I would like to share with you a tool called Autocannon. And Autocannon is a tool that is helping me to bombard my server with a lot of requests. So I would go into the next tab, and I would like to send a lot of requests to my server. And let's see, it's running. So right now it's running, my server is processing it. And all right, let's see what we have here. So first of all, I would just want to say that when we're measuring performance, we need to look at the latency, and we need to search for the larger percentiles. Here, the percentiles of requests in the 97th request was around 41 milliseconds. Okay, and we have succeeded to process 52 requests per second. And why it is important? Because usually when you make a commitment to a client of how fast your request would be, you're doing it by the larger percentiles. So then we would just stop this, and then we would do node. We would just run this, and we would see the code runs in parallel, and we can see the improvement. We would wait a second. All right, so let's see at the latency. Look at the median here was 10 milliseconds, and here the median was 16 milliseconds. This is a huge improvement for the parallel code. Okay, and here the 97th percentile is 41 milliseconds, and here is 32 milliseconds. And we have succeeded to process, let's see, requests per second were 72 vs 52 here. So we're seeing major improvements. So just remember, all of you, if you have calls which are not really dependent on one another, always just search for those patterns in your code and work with promise all, because in bigger project, those things count. Do we have time for 1 minute to see the promise implementation?
Yes.
Or we don't have? If we don't have, I can show it in the Q&A room.
Yes, that's fine. We extended up to 3 minutes more.
All right, so I would just, let's show the promise implementation itself that I would like to show you. So if you have wondered how to write a promise, okay, in JavaScript, I have to share with you one more thing. So promises in Node.js are written in C and C++ in the core, just to make them much more efficient. But let's look at a simple promise implementation. So that is our class. We have a constructor. It receives some function, an execution function, and then we're just we have to implement resolve and reject. And when we're doing it, we have to bind it to the context of that object. That is important. That is the then function. And then we have here a promise chain. That promise chain is for cases of then, and then we register another promise. So we are just pushing the unresolved, which might be another promise. Okay, and in the catch section, we have a handling error. On resolve, would just go over a promise chain and would switch the storing value all the time. Since we have a chain, and then we might have another function, then we have to resolve all of them and transfer the values. As you can see, stored values is always transferred into our next function. Okay, I have here a test with a fake server, and here I'm just I'm making a fake API call, and let's just run it and see how it's working. I would just disable all of my breakpoints. Sorry, that is a little bit. Let's just see what it, well, let's see what it made. So we're seeing that we have entered our test, and you know, all the promise has been executed. How our test is being written. So our test is being written in, let's just go over it. We're making an API call, and on then we are just registering something else. Okay, so we're doing another function and another function, and our promise is just executing the entire chain call. So that was my session about implementing promises and what are promises and what is async await. I really hope that you found it interesting. And thank you very much, all of you, for listening. And it's been a pleasure.
Thank you, Tamar. I hope you really enjoyed your first experience on the online conference. It was really brilliant. You've been talking very well. You've been keeping the structure and the attention of the audience. We can see a lot of brilliant feedback here. So thank you so much. We are now switching to the next speaker, and also we are going to the Q&A session room. You can see the URL shared in the Zoom channel, in the YouTube channel. We are sharing it now everywhere. We'll have around 15 minutes there for Q&A. So please, thank you, Tamar, and see you there on the Q&A session soon.
So yeah, right now we're waiting for the next speaker, and his name is Vladimir de Turckheim. Yay, you're here. Yeah, hello. We don't see you.
You don't? Let me turn the cam on, and that's better.
No, it's better for sure. So tell us maybe a little about yourself, and we are good to go.
Okay, so I'm Vladimir de Turckheim. I do Node.js security full-time for a company named Sqreen. I've been developing with Node.js for the last 6 years now. And that's a technology I like a lot. And 2 years ago, I've been really humbled and honored to have been nominated to get Node.js commit rights. So for the last 2 years, I have been a Node.js collaborator.
That's amazing, really. That's really amazing. Okay, good. So I suppose you may start, and as usual, after the Vladimir speech, we're going to have a Zoom chat where you can ask him, where you can ask him any questions you want. And I'll send the link to the chat. So for now, yeah, you may start. Wish you luck.
Thank you very much. So let me start by sharing my screen, and it should be good.
Yeah, it's good.
Awesome, thanks. So let's go. My name, thanks a lot for coming today. We'll give a talk about fighting memory leaks and CPU bottleneck in Node.js, because it's an important topic, and I realize that most people learn they need to know about it when it's too late. I often have people who ping me and ask me about these topics when they start to have issues in production, and they are usually in panic. So the goal of this talk is to give you the basics of worst case scenario debugging in Node.js. So if
and I hope it never happens to you, but if it happens to you, eventually you know what will be the first step to save your prod. As mentioned, I'm Vladimir de Turckheim. A couple words about Sqreen. Sqreen is a tool that provides security for web applications. So we protect Node.js application as long as other technologies. It's really easy to install. So if you have any production, any server in production, you might want to check what we do. That's probably interesting, and it's pretty easy to use, and we block attacks and detect attackers. Also, feel free to follow me on Twitter. I'm trying to get more followers than my CEO. I'm 100 followers short, so please help me win that fight. Disclaimer, this is my first online talk, so first time I give a talk from home, first time I will do this kind of talk, and I will do live demos, so anything can happen according to Murphy's Law. Let's hope for the best, but I planned for the worst. What is this talk about? That's a good question. This talk is about application crashing, maybe. Slow web application, probably. Weird stack trace, we will see what it is about. And unicorn, because I'm alone, locked down in my apartment, and my only friend is this stuffed unicorn. So I figured that you wanted to see my only friend for the last few weeks. We'll start with the first part of the talk, which is probably the most important one, which is the intro to the Chrome DevTools. And I won't even tell you about how they work and how to use them in this part. I will tell you the only thing that's important, how to connect a Node.js instance to the Chrome DevTool. So let's start with a story. Something weird is happening in your application. It can be anything. It can be your application being slow. It can be your application crashing. It can be anything. But something weird happens, and you want to know what's happening, and you have no idea. You just have a few symptoms that might be logs, that might be your monitoring solution telling you things. You don't know about it. What do I do? Then that's probably when you need to know about the Chrome DevTools. They're available in Google Chrome, and they use a communication protocol named the Chrome DevTool protocol. This protocol is all documented online. It's pretty interesting. And this protocol enables you to debug anything that happens, in Google Chrome, meaning you can debug the DOM, the HTML page, or V8. And basically, when you open the developer tools with right-click and inspect on Chrome, that's what happens. It opens a client for the Chrome DevTool protocol. And right now, you must be wondering why I'm talking about Chrome, because this is a talk about Node.js in a Node.js track. And you are right. But Node.js, one of the main components of Node.js, is V8. V8 is the JavaScript engine that runs JavaScript into Node.js, Chrome, and Chromium. Meaning that when you run Node.js, all the JavaScript code you write is actually interpreted by this piece of software developed by Google named V8. And that's the virtual machine where JavaScript runs. It's responsible for calling the function, garbage collection, handling the life cycle of every object. So we will use the Chrome DevTools, CDT in short, to debug the V8 instance of the Node.js process. So indeed, there is a Node.js process to use here. And you can't just take any Node.js process and connect it to the DevTools. You have somehow to tell the Node.js process, hey, I want to use you with the DevTools. Would you mind to collaborate with them, please? There are multiple ways to do that. And the easiest and the most straightforward one is to start the process with the flag --inspect. So instead of starting your process with node server.js, you would start your process with node --inspect server.js. And at this point, you will see two more logs to your usual application. The first one will be debugger listening on WebSocket, blah, 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 blah. And for help, see https://nodejs.org documentation inspector. What's interesting here is the first line of log. Debugger listening on WebSocket WebSocket localhost 9229. This means that the Node.js process is now opening a WebSocket server, like you would do with socket.io or the WS module. But this WebSocket server actually is expecting someone to talk to it using the Chrome debug protocol. Meaning that if you've got any WebSocket client, which is basically an upgraded HTTP connection, and you know the Chrome debug protocol, you can start to debug the instance. And that's what the Chrome DevTools do. They connect through WebSocket to an instance of V8 that listens to this WebSocket. And before we go to the demo of this part, I wanted to show you another way to tell Node.js to go in debug mode. What if the process is already started? Because in our previous example, we started the process with the -- inspect flag, but sometimes the process is already started and you cannot restart it. Let's say you are in a cloud in the Kubernetes environment and you don't want to change your deploy mechanism to make it debuggable, or maybe it's an issue that you want to debug an issue that happens only in certain condition and you are not sure what they are. So when you detect it on an instance, you want to jump on it and start to debug it, but you can't start all your applications with the debug flag. It has massive performance impact. So what you want to do is send a signal to the process to tell it, hey, you are running in a usual setup. Can you transfer and become a process running in a debug session? So I totally apologize right now for all the Windows users. This talk is really oriented toward Linux and Unix for this comment. So if you want to tell a running Node.js instance to go in debug mode, you first need to know its PID, its process ID. It's the unique ID of the process on the hardware, on the machine, on the system. So you will use the ps command in Unix, ps-aux, that gives you all the info you need. And usually I use it with pipe grep node, so I only see the Node.js instances running on my machine. That gives you the results, multiple lines, with the one you see in the second chunk of code, which reads like Vladimir de Turckheim 6035, a lot of numbers, and then node server.js. Basically, Vladimir de Turckheim is the name of the user owning the process. In that case, it's my user on my laptop. Then the number is the PID of the process, the unique ID to communicate with this process on the Unix machine. Then you've got data about the CPU usage, the memory usage, and eventually the last thing on the line, node server.js, is actually the command used to start the process. And then we will kill it. No, just kidding. To send a signal to a process in Unix, you can use the kill command and pass an argument to tell which signal you want to send. So here we will use kill, but we will use -USR1, meaning don't send the kill signal, don't kill this instance, but send the signal that actually is named USR1, that is defined by software. And in Node.js, USR1 means let's switch the process to debug mode. And then you put the PID, so the system knows to which process the signal must be sent. And then you will see in the log of the application, the log saying debugger listening on WebSocket, blah, blah, blah. Meaning that the process is actually turned into going into debug mode, which is what we want. Then when you have that, you can open the Chrome DevTools and going on the URL Chrome in Google Chrome only and Chromium, Chrome://inspect. And I think it's time for the first live demo of this talk. But because this is a remote talk and I'm trusting my internet connection and I still want to take some risks, and I want to, like without any safety net, I will go by doing that on a remote instance of Node.js. So instead of just starting a process locally with --inspect, what I will do is I will connect on Heroku and take an instance instance that is running normally on Heroku and start a debug session from my laptop to the instance running in the cloud. Let's go. So can you all see my screen? I hope so. Here I've got a Heroku application. It's a standard Node.js application. I did not go on the free plan because I wanted it to run when I did the demo, but otherwise it's a standard application. So let's just open the logs because we want to see them. Here you can see the app just started. If I do a couple query on it, I've got more logs, like there have been a GET request and /mem/literal, standard Node.js application running on Heroku. And even using a deprecated dependency, I'm really Node.js user. And as you can see, the application just started, and it's not written that the debugger is listening to anything. And if I go on Chrome inspect, it doesn't detect any instance. So what I need to do first is to connect to Heroku in SSH to the server. I need to connect to the server where the application is running through SSH. To do SSH on Heroku, it's actually pretty easy. You will need a tool named the Heroku tool belt. That's basically the CLI for Heroku. And then you will run a command named ps:/exec. It basically means into Heroku, and that's Heroku specific. It says, hey, can you start a SSH session between my laptop and one dyno of this application? And then you put --app to tell it which application you want to connect to. Of course, I am logged into Heroku with the CLI first, so he knows, Heroku knows what my user account is. So when I do that, and now it starts to get risky because I'm doing things on a remote server in a talk, things you should not do. It says, hey, you are connecting to web.1. It's the name of the dyno. If you have multiple dynos, you need to select which one you want to connect to. On demo April 2, that's the name of the application I created just for this talk. So remember, we want to do ps:/aux because we want the list of the process, because we want to identify the process of the Node.js process. So here we've got a list of process. First of all, we've got the user account, the PID, CPU, memory things, and then the command used to start the process. So we are looking for a command starting with Node. And here it looks like it's our command, the Node server we are looking for, node server.js. So we check the PID, and the PID is 52. So now we can send the signal, so kill USR1, and then 52, and nothing happens. Okay, nothing happens, but maybe that's expected. Let's see the logs of the application. So if I go on the log of the application on Heroku, I can see that there is a new line of log, debugger listening on WebSocket, localhost 9229, the URL for help, go on documentation. So yeah, we managed to change the state of the Node.js process. It went to running in the usual way into running in debug mode, meaning you can connect now the inspector to it. But here it's still not available in the remote targets. And that's actually expected. So let me log out. So there is something interesting, that remote target can listen on any URL you give it, but I can't just give the URL of the Heroku instance to Chrome because Heroku does not open the port to the whole world. The only ports Heroku opens to the whole world are the HTTPS ports. So I cannot use a WebSocket client to directly connect to this server. What I need to do is find a way to make this port on the remote server available on my local host, on my local machine. And thankfully, there is a solution through SSH for that, and Heroku exposes it in its client too. It's called port forwarding. So what you want to do is to forward the port 9229 from the remote instance to your laptop. So you use the command ps:/forward, and then the number of the port. So if I do that, It will still take a few seconds to connect. And then it tells me that it opened a server on port 9229 that is forwarding to web.1. Remember, that's the name of our dyno, 9229. That means that on my own laptop, on my own computer, my MacBook at home, there is currently the port 9229 that is opened, and any connection I would do to that will be just forwarded through SSH to Heroku, and I would not need to know anything more. So now when I get to Chrome, I see that there is a Node.js instance that is available. Once again, I'm on Chrome // inspect. And here I see that there is a Node.js instance connected to my local computer. So if I connect to it and I try to run in the console, I try to get what is the host name of this instance. And it tells me it's all this thing. And that's not the host name of my laptop. It's the host name of the Heroku server that is running on AWS Cloud. So I actually managed to connect remotely through the dev tools, and I can now browse the source of the code, get the memory, get the profiler information, run anything I want in the console. I can do anything I want through Hello on this instance from my laptop. Let's say I want to go back to Heroku log. I see that the console.log hello I did is available directly in the logs of the instance. So when I've done what I want to do on the Heroku instance, I restart it because I don't want it to stay in debug mode for performance reason. And that's the first part of my talk. With the live demo of connected to Heroku, it was the hardest demo and we survived it. So oof. There is an alternative way to connect to connect to a debug session. It's using the inspector module. The inspector module is a module available directly in Node.js. So you do require inspector and it will be available. And it's actually a client for the Chrome DevTool protocol. It enables you to run the DevTool protocol on the local instance if you want to debug Node.js from Node.js, or on another V8 if you want to debug Node.js locally, remotely, like another Node.js instance, or even Chrome or Chromium. You can debug from Node.js with this core module. So if you want to write CLIs or tools that automatically detect memory leaks or CPU bottlenecks with Node.js on another Node.js application, that could be a fun follow-up for this talk. So now let's go to the practical part, because we know in theory how to connect to Node.js application with the debugger. And now we need to know what can we do with it. And the first example will be debugging memory leaks. So let's say you are checking in your monitoring tool and you see that the instance, the server restarts a lot. So since you are a good developer, a good DevOps, you decide to check the logs. And the logs are actually really, really helpful because you see that the application crashes with these logs. Okay, these logs might be a bit complex. At the top, we've got a section named last few GC for garbage collections. Then we've got a section named JS stack trace. We expect some JavaScript code, and there is at least no JavaScript code in it. It's C and C++ code, so it's not really helpful. And there is actually one line that is extremely important in these logs, and that we really want to see. It's this one. Fatal error, ineffective mark compacts near heap limit allocation failed, JavaScript out of memory. The important part, the part you want to know about, is JavaScript out of memory. This means that the process crashed because there were too many things in the memory. So there is probably a memory leak or a too big memory exhaustion. We need to know what's happening into the memory of the process. And we know it's the JavaScript memory that is too big. So we want to understand what's inside so we can understand which part of the code generates too much objects that crowd the memory and that the garbage collector cannot fix. So let's collect what's called a heap dump. What's a heap dump? Glad you ask. A heap dump is a file showing the content of the heap memory of V8. Basically, it contains all the JavaScript memory of the process. It might contain sensitive data. Let's say you are comparing passwords and you decipher them, or before you hash passwords, if they are not garbage collected, they will be there. Every piece of memory of your process will be available in a heap dump, but we will see how to make them a little bit safer. And my math teacher in high school used to say that example is better than speech. So let's go for a second live demo. And I'm expecting all of you to be cheering behind your laptops at home and people around you being surprised. So let's go to this live demo. Let me just start a local server, and here it is. So in the previous talk, you were introduced to AutoCannon, and I will use another tool that's basically the same thing as AutoCannon, but it's named AB for Apache Bench. Basically, it makes a lot of requests on an HTTP server. So I use the -C argument for concurrency and the -N argument for number of requests. This means, can you make 15 requests in concurrency until you reach 10K requests on this server? So let's do this. So now it's running requests. We can see it's already halfway done. I will use this time to drink a bit. And it's done, and we have the percentage of requests within a percentile. Okay, that's interesting, but that's still not a memory dump. Vladimir, stop lying about what you're showing. Okay, I will be showing a heap dump now. So here, since I started my application with the --inspect flag, I can see that it is actually running and available in the dev tool. So I will open the dev tool and I will go to memory. Okay, it's pretty empty. What we want to do is we want to click this button that does take a heap snapshot. But before that, we want to call this little garbage, which means, can you please trigger a garbage collection? Meaning, can you remove all the content of the memory that is actually removable? That's actually pretty important because, first of all, we can remove secrets that are not supposed to be leaked. And we can actually remove noise because in the file we will collect, that will be really noisy. So we click on the button to collect a heap snapshot. And it takes a bit of time. And that's pretty much why I did that on a local instance, because if you do that on a remote Heroku instance, it takes like 3 times the time of that. So the first thing we need to see is, if you see my mouse, is the size of the heap snapshot. Here it's 70 megabytes. And we have all its content. So inside it, we've got the content of everything in the process, sorted by constructor. So for instance, we know that there are like 143K objects in the process, and we have 15 instances of set. We have a lot of URL inside the process. Okay. We can check the columns quickly because they are interesting. The first column is actually the size of the item. So if I take this object, I know it has a size of 24 bytes, but it's its own size. It also has what we call a retained size. The retained size is the size of all objects that are actually, that can't be garbage collected because this object, 73.4 blah blah, has a pointer to them, meaning that if you are able to garbage collect this object, you will be able to garbage collect this amount of memory. And the second part of the panel is interesting too, because that's the retainer, meaning if you take an object, you can check every object that has a pointer to it and prevent it from being garbage collected. So for instance, this object, I don't know what it is, I have no idea what it is. Looks like it's a library. Okay, it's a library, and it's held by a lot, only type 9 in another object. Okay, So we are still trying to hunt a potential memory leak. So the second thing we will do is we will add more traffic to the application. So we run A/B again. That's enough. And we will collect a new snapshot. So this one is a bit longer to collect because there is even more things in memory, because remember, there is probably memory leak in that example, otherwise my talk would be useless. So it takes a bit more to compute for the tours. So let's see the size. You see it's almost 100 megabytes, and we were at almost 170 megabytes. Once again, we don't really see directly what's leaking. So what we do, we use comparison. And when we do comparison with snapshot 1, it actually tells you what objects are available in the new snapshot that were not in memory in the first one. So we have new columns, we have number of new items, number of deleted items, the delta of items, and we also have the size delta for the items. So what we want to do when we look up for a memory is find the biggest size deltas. So it's probably an object because closure and arrays are internals of V8. So we see that we have a lot of new objects. So let's check these objects. Okay, we see that we have a lot of objects that are 2088 in size. They are probably the same kind of objects. So let's quickly look inside. Okay, it seems to be an HTTP request. We can recognize it because it has the class incoming, and you need to know a lot about Node to do that, but it's pretty coherent with the fact that I've got also a lot of incoming message in my memory. An incoming message and server response, you better know them in Node.js under the name rec and res. Rec, the HTTP request, is an instance of the incoming message class, and res, the HTTP response, where you will write the response, is an instance of server response. So I see that there are a lot of them staying into my application, and that's actually really weird, as if they were kept in memory. So let's click on this one and try to find its retainers. So we can see that it has a retainer here, and each time we've got items, we have the line of code where they are created. So this is Node internal, this is Node internal. Okay, this doesn't look like Node internal, maybe literal. This looks like user code of my application. So we click on it, and it will actually bring me to the source code of the application. And here I see I've got an express controller, and each time there is a request getting inside, it calls getObject on rec and get the UID back. So let's see what getObject does. It creates a new object with, as a first parameter, the request and then a UID, and then it adds it to a store. But I don't see any code where things are removed from the store. So that's where the memory leak happens. We are writing in this store, but we are never removing from it. So here we've got a memory leak. I will just quickly show you something really interesting that could have made our life even easier. So I just benchmarked another endpoint, which does exactly the same thing, but with one small difference is that it creates the object differently. I will explain you right now what this means when the snapshot is available. It will take a few more seconds, and that's why live demos are dangerous, because you lose time in your talk, blah, blah, blah. And now we do comparison with snapshot 2, and we can see that there is a new class named item, and there are a lot of them, like 2,000 of them. So if I click on it, I see that this is a class that is leaking, that the object instantiated from this class are leaking, and I already have the stack trace here to call. So it's like exactly the same code as before, but instead of creating the object with just bracket, we create the object with a class. And it makes our life way easier in terms of debugging, because we directly see what is leaking inside the application, because the heat dumps are sorted by class. Sorry, I stopped sharing my screen. That was not what I wanted to do. So let's go back to our slides. And now let's move to CPU bottlenecks. That will be a shorter part. So let's start with another story. You see in your monitoring tool that your server takes a long time to answer certain endpoints. And don't forget that in Node.js, in the list of best practice, the first one is always don't break the event loop. Actually, Node.js is single-threaded, meaning that if you've got one single synchronous operation that takes a lot of time, your server will be blocked doing only that. And it could jeopardize the whole application. So when this happens, to debug it, what we want is a CPU profile. What's a CPU profile? It's a file that will tell you which functions are running at one point. So during the collection time, the profiler will sample every n milliseconds the name of the currently running function and why it's running. This will highlight the functions that are slow, but the fastest function won't be shown because it's like a ticking system. And if a function runs quicker than the ticking system, it won't be shown. It will follow the JS execution, meaning that asynchronous operation will actually have an impact on it. And once again, I think it's better to go directly with a demo. So let's go back to our application. I will run an HTTP request on a certain endpoint, and I used the time method to know how long it takes. And it looks pretty slow. Should be good now. Please don't demo effect by running forever. Come on. No, it should be now. Okay, so that's a total demo effect and something had to go wrong. So it ran for 22 seconds. So let's reduce the size of the string. Okay, let me do something quickly. Okay, better. So now it should run in approximately 7 seconds. No, yes, 7 seconds. Okay, so now I just restarted the instance. Let's connect back to the debugger. And this time we will use profiler. Profiler, it's not a one-off situation. Profiler, you start it and you stop it because you record what's happening over a time frame. So we will just start it here with start CPU profiling. We will trigger a request because we need something to happen while we are profiling. So you need some activity, otherwise you won't see anything. We wait, and now we stop the profiling. And it gives us this weird file that we call a flame graph. So I will just look up to the very first part of the flame graph. Please do. So a flame graph actually is a stack trace with time. It tells you here that the function onConnection has called the function socket, that has called the duplex constructor, that has called the writable constructor, that has called event emitter. And then you see there is an asynchronous operation. So the stack trace is broken and we need to go there. It has called emit, it has called all these functions that have been called. We have another asynchronous operation and we call that. And we've got the time. So here I can see that it has been running from 3.5 k milliseconds up to 12.5 k milliseconds. And I know that the functions here have been running for a very long time. What's important is the function at the bottom or at the top of the flame graph. So in our case, it's at the bottom because it's a top-down flame graph. So once again, this function has been calling this function, that has been calling this function, until this function has been calling this function. You can see that this function is named module.export, and that's probably not a great name if we want to debug. It probably would have been better if I gave it a real function name. But at least this function has been calling a function named validate input. So let's click on it. And here, Chrome tells you, hey, this function has been running for 10 seconds, 9k milliseconds. It's probably really, really slow. And that's actually this slide that has been really, really slow. And if Liran or anyone who is used to Node.js security is looking at this code, what they have seen is that this regex is actually what we call a backtracked regex, meaning it contains a redos, a regex dos. Regex dos is not the toggle of this talk, so feel free to check it. What you need to know is that it's a regex that can run for very, very, very long time. And since it's running for a very long time and it's JavaScript and synchronous, the server is blocked on running this regex, this exact regex, for a very long time and cannot do anything else. So to fix this problem, you either have to update the regex or time bomb it. I recommend to check the module named VM in the core of Node that enables you to time bomb synchronous piece of code. That's really powerful, but highly unused. That's a great hack. So thanks to the CPU profile, we were able to detect where the leak of CPU happened. And here you can see they look very, very small because the other functions have been so slow. We have the methods that are called for answering the HTTP requests. Okay, let's go back to the slides because the talk is almost finished now. Please let me share. Okay. So let's wrap up. I hope you all love the Chrome Dev tool now because they are probably your best friend when something goes wrong. So in wrap up, I usually give a few advices to the users. We have 5 more slides. So the first advice I can give you is monitoring, monitoring, monitoring. If you remember, in both scenarios I gave into this presentation, they started by monitoring gave us something weird. Monitoring told us the application was crashing. Monitoring told us the endpoints were slow. Monitoring, monitoring, monitoring. You have to monitor performance. You have to monitor for security. You have to monitor for the infrastructure, because otherwise you don't even know the first thing about the health and the security profile of your application. Second one, use classes. Don't create objects out of the void. Quick parenthesis, all these tips works not only for Node.js, but any JavaScript application, because the methods of debugging I showed you today are also available for front-end application in the browser. You can't connect to the remote, but you can always start a web page and open the Chrome Dev tool for this page. So use classes. I know it's not popular amongst React people, but use classes. It will save your life in time of memory leaks. Name functions. Naming functions is the best way to find it easily in a CPU profile. So here I created dummy code examples, and it was pretty easy actually to find the problems. But in the real world, your code is much more complex than my dummy applications that don't do anything. So name things, give them class names, and you will be saved. Don't panic and trust the engine. V8 is like one of the best pieces of engineering ever made, and you can trust it to save you and the tools around it to make it up for you. Human write code, human make mistakes. This will happen in production for you. Maybe not today, maybe not tomorrow, maybe not in Node.js, maybe in Python, maybe in Java, but these principles are the same for all languages, all platforms. This will happen to you. For instance, you can read the great blog post about from the Discord team that explains they switched from Go to Rust because they had a different memory management model, and they had to understand the memory management model of Go to understand why their application was slow. Also, if you're interested in the performance of Node.js, you can check the blog post by Netflix. They've got one of the most amazing teams in the world regarding these topics. Debugging, and that's the last quote of this talk. Debugging, it's like being a detective solving a crime, but you are also the criminal. Or if you are not the criminal, it's one of your coworkers. So when you write code, don't forget to write it as if the person who will have to fix the bug is a maniac who knows where you live. And also when you write code, think about not dying when things will go wrong, because that's where you will lose time, you will lose money, and you will lose customer. Thanks so much for your attention. I assume you have been an amazing crowd, but it's really hard to say. I'm sure you have been. So let's keep in touch. You can email me or contact me on Twitter. I'm very present on Twitter. It's really hard to give swag on a remote conference, but I tried to. So there is a Node.js security checklist. It's a free checklist of the list of things you must check if you have an application in production using Node.js for security. Check it, it's on Sqreen blog. The slides are directly online, so feel free to Google them. And here is the link for the Q&A. I think it's on the chat for the...
Yeah, that's exactly what I sent to the chat, so I suppose that people already seen it. And I loved your spontaneous jokes, really.
Thanks so much.
It's because I understand how hard it is to speak to basically no one, you know, so you try to mingle it, and it was amazing. So thank you for such an amazing speech. You did a great job, I suppose. So, and, yeah, I suppose you may go to the QA room and wait till people will go there and ask you some questions.
Thanks so much for having me today. Thanks so much for being an amazing host, and have a great day, everyone.
Thanks, you too. And we are going to have our last speech on Node.js. And this speech is going to be from Liran Tal. Are you here? Let me know. Yeah, so hello. I don't see you. I suppose we have to wait a little bit.
Hi everyone, that's Geekle online conference and we are back on live. Our next speaker is ready to go. Please welcome Mr. Liran Tal from Snyk Node.js Foundation. And the topic would be about malicious modules on NPM, a series on unfortunate events. Hi Liran, how are you? How's it going? You're muted now.
Oh, yeah. There we go. Yeah.
Cool. How are you? Are you excited?
Very excited, thank you. Setting up everything here so we can go live when we're ready.
We are ready. I can see your screen. We can hear you, so everything's fine. You're ready to go.
Sounds good. Can we get started, or are we waiting to catch up a bit on the time?
No, we are on time already, so you can start.
All right, awesome. Well, hi everyone, and thank you for joining. And it's my pleasure being here and chatting with you about security matters on the NPM ecosystem. Today, I want to talk to you about malicious modules on NPM, a series of unfortunate events. So as you know, I've probably heard about some incidents that have been happening on the NPM ecosystem on JavaScript, and not just on that. And today I want to actually walk a little bit into it in terms of examples and code and what can actually go wrong and what can we do together as all of us as citizens of open source and this ecosystem. So I'll start with introducing myself. My name is Liran Tal. I'm a developer advocate at Snyk, where we build developer-first security tools for open source. I'm also involved with several security activities, such as the Open Web Application Security Project, which is also known as OWASP for short. I'm an active member of the Node Foundation Security Working Group, so I'm helping triage vulnerabilities from time to time. If you want to join that, we could always use a bit of help, and this is like an open source and open community kind of project. So if you want to join, if you want to help in, just find me on Twitter at Liran_Tal, or ping me in whatever medium is most easier for you to access. So with that, I do want to kind of talk to you on what we'll be doing today in terms of this session. So I want to talk to you about black clouds and silver linings in terms of everything that could go wrong in our ecosystem and some things that have gone wrong. And this kind of having this notion that with the growth of this open source software, that we all are using, we can't forgo the importance of security aspects that are affecting both developers and maintainers alike. So in this talk, we'll talk about discuss specifically some software supply chain security. So things like getting better insights into dependency management that we all are dependent on. Learn more about popular vulnerabilities and how to fix them. And last but not least, I want to talk about some security controls that you can have in the NPM, the Node ecosystem. So everything around JavaScript and everything that we have to protect you. This is, of course, by all means, not a very comprehensive best practices, but at least a very good starting point for you. And I have a lot of resources afterwards, so you're always welcome to just ping and reach out. So let's talk about NPM, right? The largest open source repository of application dependencies, spanning over 1 million packages. I think 1.2 million last time I checked. So it's pretty big, right? And I do want to get this statement, kind of set a stage for this talk. I want to open this with this quote from a research paper from Zimmerman et al. That dived into a lot of the aspects that open source security has in it, and just let it resonate for a bit. That installing an average NPM package introduces an implicit trust on 79 third-party packages and 39 maintainers, creating a surprisingly large attack surface if you compare that to other ecosystems, for example. So NPM is kind of heavy on reuse, right? We write a lot of Node modules. We also use a lot of Node modules. There are some Node modules that are built of under 10 lines of code, some under 40 lines of code. Maybe that is not necessarily bad, but it should indicate to you that, I think as JavaScript engineers and NPM as a repository has a unique culture of small purpose built modules and kind of a tendency towards reuse. So let's take a practical example. If we, for example, try to compare Java to NPM, if we take Spring as a web framework, it has 10 transitive dependencies. And if you compare that with Express, it has 47 transitive dependencies. Express is probably a good case in terms of most of those modules are probably built by the maintainers of Express, but not all the time this is the case. So you should actually know about that and understand that this is an actual concern that we have. So yes, a testament of JavaScript's incredible growth is probably npm becoming the largest open source repository with more than 1 million packages, as we said, more than 70 billion downloads a month. So it's a really big repository. And what I'm getting at is the biggest repository also kind of invites some big risks that we need to understand and be aware of. So first of all, it's I'll start with it's a very lucrative attack playground in the sense of compromising one popular package impact tens or hundreds of thousands of other packages that are transitively probably dependent on it. And that translates at the end of the day to like millions of downloads by consumers, by you, me, all of us together in this game. The other thing is it is a very open ecosystem, very much unlike other ecosystems as well, in terms of anyone can submit any module that they want, without being required to like specifically validate their identity through something, very identifiable, like a mobile device or something like that. So just, signing up with an email, create a package, publish it, and that's it. Even if that's a malicious package, out of 1 million packages, that's probably it will take time until someone catches up with it. So it's very lucrative. It's very open. It's also very difficult to detect as kind of like maybe a last item. But before we even get to that, let's think about this thing where we're talking about an open ecosystem. So we have a very big disconnect at the moment between npm from what you publish to the source code that actually used to create this package. So there's nothing that says, when the package has been published to npm, it actually relates directly to this and that tag or branch on, GitHub or Bitbucket or something like that. So there's total disconnect, and you could have one thing on SEM and the other thing on npm as like a tarball. And then the other issue is the bunch of people that are maintaining the software on something like GitHub, like an open repo, is not the same as those publishing it. So there's again a disconnect between committers on like the Git repository and then the publishers for that on npm itself. And then it goes again back to difficult to countermeasure in terms of npm is really big. To auto detect a lot of malware in scale, it takes a lot of good technology and resources, people developing all of these things. And I think we're not yet there yet, but there are some indicators that npm is kind of like growing into that space. Recently, they had shared around this thing called Insights API, which is in kind of like closed beta, so probably worth to sign up and see what they have to like help us all around this context. So moving on, I want to talk to you about, the small world with high risk, this study of security threats in the NPM ecosystem that, we can pull some interesting perspectives on the state of security in our JavaScript ecosystem just from this research paper, which, as you can see, hasn't been published long ago. So one of the highlights from this research paper is just how much we are reliant on transitive dependencies. And in this chart, we see that by linearly adding dependencies to our project, we actually incur a super linear increase in those transitive dependencies that are added as a result. And another 2019 academic research paper that explored the differences between Python's pip, which is Python's repository, and JavaScript's npm, which is ours, in this ecosystem, found that an average npm install will yield 4 levels of nested dependencies of packages that you may not understand exactly what is the security testing, the security posture of, etc. So in this research, this one from Zimmerman, they actually found out that when you install an average npm package, a user implicitly trusts around 80 other packages due to these transitive dependencies. And I can't help but wonder how many of us, are truly aware of all the dependencies that we actually have in our projects. Do we trust these maintainers? Do we know if these maintainers have, ran any sort of security test on their packages? Which it is all in good faith, but we need to understand that, we are bringing in these dependencies and it carries risk. So how about the fact that up to 40% of all packages rely on code known to be vulnerable? Again, also insights from Zimmerman's, research paper. Let's talk a little bit about malicious modules that take different forms at all. in how they manifest and how we actually have seen them. So there's typo squatting attacks, there's compromised accounts, social engineering, and we haven't even seen yet a case, where the NPM was actually breached or something like that. We probably will not see that. Hopefully, we'll not see that. But all of these three cases at the very least, have been happening, and we've seen incidents around it. So malicious modules. I'll start with the first one called crossenv. It happened a bit while ago, but we can learn some things from it. So when you wanted to install crossenv, which generally speaking, crossenv is a good module to manage your environment variables. But if you wanted to install it and you installed maybe the wrong thing, like if you typed that one in, it would actually install a malicious package, because it actually needs to have a dash and not without a dash. But if you installed it, and we take a look at how the package.json, for example, looks like from this malicious module, you can see it's called crossenv like that. It's been defined in it, but it actually bundles the real crossenv to give you a sense of an actual functionality, even though this is not the same, it's not the same module. But more than that, it has this post-install script that when you install packages, npm as a command line package manager, client-side package manager allows packages to run arbitrary code in the same, in the same user that actually runs npm itself as well. So generally speaking, those packages can define some hooks, like when you finished installing the package, I also want you, which is basically downloading a tarball and extracting it. I also want you to execute this package setup script, which if you did, it would go ahead and run all of your environment variables and send them off to an attacker, to the malicious user here. Let's see if you can spot the malicious package out of these options. If you were to install CoffeeScript in 2020, would you install the first or the second? But the thing is, CoffeeScript, the one that you actually install is not the left or not the right. It's actually CoffeeScript without just spelled correctly. And we're seeing these packages, malicious packages, happening a lot. This is like a snapshot from the Snyk vulnerability database. It's just open, so you can go and browse through different ecosystems and just see all the CVs and vulnerabilities that are out there, including malicious packages. You can see that we're seeing them quite a lot. And this is an example for their request package, which as you can see, there's different ways of typo squatting it in the npm ecosystem. So what we learned so far, at least, is there's post-install script that we are aware of, and they can do something like call home with the base64 payload. So maybe they get passed through firewalls and things like that. How did we find out about this malicious package? So actually, it was something that the community found out about it. And we actually, when we did find out about it as a community, we also realized that this is not the only malicious package that the user had actually created. They actually typo squatted 40 other packages as well, trying to kind of like trick users into installing the wrong package. Let's talk about something else, about get cookies, which you could figure out that this maybe is something to allow you to parse and manipulate HTTP headers for cookie data, or does it, right? So what get cookies actually is about is, in fact, it's nothing less than a command and control backdoor that allows anyone who knows that this is running on a remote server, and any victim who had installed it, it allows a remote user to actually execute remote commands JavaScript on a running web server when they bundle this dependency. How does it work? These are all real stories, right? So this is a real dependency. How does it work? The attacker actually built a pyramid of all of these meta packages that actually just wrap get cookies, because no one looks behind a node module of a node module of a node module, but still it's just 3 of them out of like 1 million packages. So to get it to actually kind of like circulate around the ecosystem and gain some downloads, they were able to actually in reality compromise and hack the account of the maintainer of mail parser, which may have probably used did not use two-factor authentication, or may have used weak passwords, and so they were gaining a lot of they added get cookies as a dependency to mail parser, and basically gaining a lot of monthly downloads out of that. Now we said command and control. So how does this backdoor work? This is like a real backdoor. I've kind of like we'll go through the process. It's 40 lines of code payload, but it's not a lot. But we'll need to run through it through some of the slides. So as you can see here, I bet this looks a bit familiar. This harness function is like a function signature of an Express web application server, which that's what it is. And the heart of like the whole thing, the whole payload is actually this kind of piece of code where you see that at first it tries to allocate 64 bytes of data onto something where it can actually like inject some data into. Then it looks for like a specific string in the headers. So maybe like something that it can actually send over the HTTP to control and like send data or send commands. It will go and parse it in little endian form. And then we can distinguish from these 3 different commands being handled. So one of them allows you to go ahead. One of them allows you to go ahead and reset the buffers. So like the buffer is empty. The other one is actually going to push data onto the buffer. So we can push our JavaScript code onto the buffer. And the last one is all about executing it. So when they have finished the attacker sending their code, they will send it off and execute it. So you can see all of this payload here, and you can go through it. And the way that something like that works is, imagine someone is just if they are able to interact with a web server that has this malicious package being bundled in. Just imagine that they are just sending an HTTP request. You do not need specifically to be authenticated if that is not required, but they add their data in this X secret kind of like HTTP header. And then you see these commands and these strings afterwards are basically used to reset the buffer, load some JavaScript code, and at the end execute it. So all of these real stories from of course that has been happening on the ecosystem with mail parser and get cookies. Mail parser got published with 3 versions, all of which were vulnerable. We're basically carrying off this malicious package as well. So one observation we can take here at this point is, security by code review is really hard because we have to get it right all the time when we do code reviews of packages by packages. But that's not the same for attackers where they have to be, lucky just once to get in. Let's talk about ESLint scope 372. It's basically a malicious package that was published to the ecosystem as part of the whole ESLint project, or the whole ESLint scope specific package, which is okay, just not this specific version. And what happened there is, when ESLint scope was actually compromised, what it did is something very similar to what Croissant did, a year before that. Instead of ESLint scope, instead of getting and gaining environment variables and sending them off, because you usually have maybe sensitive data there like API keys and passwords, what ESLint scope did as a malicious package, it sent your .npmrc file, which is where as a user and as a maintainer, you have your tokens. And so if you have your npm tokens, then this is something that we can use now to maybe access your account if you maintain some of this. So this happened, as you can imagine, millions of downloads for ESLint scope, since this is a very very prominent project in the ecosystem. Not millions of downloads though for the malicious package. So we actually got that in time, and what was going on there is like the same thing that we've seen before, right? How do you do that? Basically, there's a post install script that you execute, and here is the payload for it. That's a pretty interesting thing. So if you think about static code analyzing and like what can you do to figure out all of these malicious kind of like code and payload that is happening. So if you think about it, if the code is not existing there, then it's really hard to find it. So what they have done here when they compromise this package is they're actually doing a GET request outside to something public like Pastebin, where they have maybe like an encrypted source of, or just not like an unencrypted one of what they actually want to evaluate on runtime when this script gets executed. And that's what they actually did, right? Those of you who might be looking very closely here can see that there's actually a JavaScript mistake in a sense here. So there's a stream being opened to this HTTPS host, except when the data payload just gets back, it's going to go and try to evaluate it. But the fact is it could be a very big data, so it will not actually fit into that chunk of the data that is being handled for us in the stream traffic that we get in this function. So when that happens, there's going to be probably like an error being thrown. And this is how we found out about it when someone was actually being attacked and kind of like infected by this malicious package. They had this error, and they opened an issue on GitHub and say, no, maybe this is a virus because it looks very weird and it likes doing something that I would not expect it to do. So this is how we actually found out about these kind of things. Who depends on the ESLint scope. So if you're not aware of this project, things like Babel, like Webpack, all of these are dependent in one way or another, at least at that point in time. Now, it wasn't severe in the term of its impact on the amount, like there wasn't millions of downloads as far as we know to this package, but it was severe enough for the NPM team to just basically invalidate all those tokens that they issue through NPM-RC and stuff like that. Invalidate all of them prior to this, like after this has been discovered, and at least from their estimation on the blog announcement back there is about 4.5K accounts that were compromised through this. So maybe a second observation here. So ESLint scope published a package on NPM, but these malicious actors did not have any access to the GitHub repository, which would have been maybe easier to spot. And this is when we said, big ecosystem, big risk, etc. This is like there is no connection between the source code and what you get on NPM, the actual tarball that is being published. So something we should think about. But again, like how does something like this happen, right? Like how does someone compromise however they build their malicious package? How do they compromise something as significant as the ESLint scope or mail parser, which have hundreds of thousands of downloads or millions of downloads? So a security researcher actually evaluated the possible case of basically people using weak NPM credentials, weak passwords to a sense, and managed to gain access to what accounts to be around 14% of all modules on NPM. So he was basically testing to see if they are able to gain publish access to modules on NPM, right? And they had actually managed to get that to about 14% of all NPM modules. There's a link here below. I'll share my slide afterwards. This is the person, and these are the notes. All of these are real cases from the ecosystem. And maybe you are familiar with at least some of these. Just a sec. Slides. There we go. Maybe if you are familiar with some of these modules that they were able to gain access to, because if we convert these 14% modules of all NPM, they actually account for 20% of the total monthly traffic on NPM. And gaining access to things like React and Moment and Express and all of these modules that they actually were able to gain publish access to. So it is shocking, and let's figure out how does this happen, and so that we can learn from it and not do the same mistakes. So for example, Koa maintainers had their password set to password, which is probably a bad idea. So please do not underestimate your credentials to NPM, GitHub, or anywhere else. About more than 1,000 users, just had their username, their password set to their username to publish a package for their NPM user. So again, telling you do not use bad passwords. Even if you used really, if you think you are using a very good password in terms of, maybe it's very long, etc. The thing is, you have to take into account that a lot of time passwords due to data breaches get leaked. And they were able to actually compromise those accounts and gain access by basically consulting these leaked databases. And basically, for example, one of the users that was directly controlling about 20 million downloads a month for a package simply used their last known password, which was leaked, by just adding one character to it. So it was very easy, even if it was not exactly the same one, to just realize what it is. So again, good security hygiene starts with your developer practices, things really as easy and simple as working with passwords. And to Efrain, we'll talk about it to the last part of the slides. So how about the fact that one of those security research papers mentioned earlier that it found 61% of all packages on NPM that could be considered abandoned, and they defined an abandoned package as one that did not receive any new version published in the previous 12 months. Now, this may be something that you would, counter argument with things like, maybe it's a package that is very mature, there's no many updates necessary, except we've been aware that, event stream happened. So, November 2018, the event stream, to my opinion, one of the most sophisticated and biggest issues that we've seen around like open source malicious modules in terms of people being able to take over event stream. And I do not want to go into the details because it's like a long story of how this whole thing folded out. So there's this postmortem here. There's a whole there's a bunch of blogs around it. This is one from the Snyk blog on like a postmortem of what happened here. But to make a long story short, what happened is basically social engineering attack that get attackers to actually gain access and control over a popular package because they had social engineering the way in saying that they want to help, they want to contribute packages. One of those were then found to be malicious after several versions, and it actually got them to target specifically developers of Copay Bitcoin wallet application and injecting malware there to steal Bitcoin money. So they specifically targeted developers in the way that the build flow actually works. And most of us would not even be familiar with event stream because it's not really used as like a direct package, but it is used a lot as an indirect package. And the thing with event stream is that it shows us just how easily attackers can infiltrate open source software supply chain by just adding a malicious dependency to a trusted component. It is actually about maybe 1,000 packages behind from being the top package, event stream itself. And still this has been one of the most dangerous things that, and the scariest thing in my opinion that we've seen happening on the NPM ecosystem. So that's not even close to the top package, and it has made significant waves. Maybe the last observation for us in this module basically is due to the increased use of Trustpilers, reviewing actually and comparing source code, even if you could do that between actual source and what is actually distributed on NPM is very hard because a lot of time, especially around front end, you will go ahead and have like a distributed a dist folder that gets transpiled. So not like reviewing that doesn't make a whole lot of sense. And so this brings us to talk a lot. All of these stories we talked about, things that could go wrong, and I'm not here to preach that we have a bad ecosystem. Far from it. I think this is an amazing ecosystem to be part of. But this is all to educate us on things that can go wrong, and then be a little bit more vigilant on on the action that we do and the packages that we install, and just being a little bit more responsible than just going into the terminal doing npx something without understanding what you're installing. So just having this mindset. So dependency management, as all of this brings us to, is it's very hard to imagine, I think, anyone building anything today without using open source, whether it's backend, front end, web, or anything else. So dependency management is hard. These are libraries that we use across projects spanning beyond not just Node.js and into other JavaScript platforms as well. And this ecosystem is very convoluted. There are many libraries, and other nested libraries, and future libraries coming out. So how do we make sense of it? What can developers, when we're talking here about security, what can they do to secure their application a bit better? To have it is also a hard time to actually keep up with all of these nested dependencies and understand all of those security implications. And so let's do a mental exercise, right? Imagine you're building a Node.js app. Imagine you're building a JavaScript app. Most of the time, your mental image of the application that you're building is this blob, except, it shows you, it provides you this wholesome, end-to-end functioning application, except in reality, what you actually write in terms of your own code is probably a lot smaller. And you don't have to just trust me on this. There's many research data from Gartner and those kind of firms that are actually mining these data, understanding what's going on. They're saying most of the code that's getting shipped, getting deployed, getting built is made out of 80 or 90% of open source code, not like proprietary code that developers write in organizations. So this is what we have to handle as developers and understand this kind of security risk. And it also brings me to like the notion of what is the maintainer kind of point of view here, like how do we roll out security fixes? So for example, dependency management is hard. So it's not just for us developer, maintainers also have to kind of like keep up with those security fixes and also release them. So the screenshot shows you like a GitHub issue where developers actually surface a problem in which the maintainers have released a version to fix it, but they released the version, the new one that fixes it, as a major version, as 3.x versus 2.x. And that makes automatic upgrades a little bit slower and more complicated, because then it's not a minor or it's not a minor semver kind of upgrade or a patch. So if it's a major one, maybe we need to like take into account maybe there's like breaking changes and API changes and stuff like that. So we need to understand also how to roll these out in a better way as maintainers. And so this brings me to like another interesting insights, and that is how often we, as both I think maintainers and developers are on like this autopilot mode where we don't even consider security risk and attack vectors that are, in the most basic things, things like a log file. So why would that even be a risk if you're using a log file? So let's imagine this case, which is a real example that I've reproduced. And imagine someone contributing something to you and your to like an open source project. So you see there's like a couple of packages there, and like basically I didn't even change them. I really just upgraded your versions. And if you were really, really cautious and you did not know them, of course, you should have gone and checked that what is types node and what is octokit rest, and just realize these are like actual okay packages. But if you take really good notice here, you'll see that the log file itself, in this case, yarn.log and package log behaves the same. Because it is actually very big in terms of changes, GitHub will actually go and make it show it like that in terms of it will be collapsed, and so you will not see all of the changes there, because who can review 500 lines of code changes. But if you were to go in and see what was actually going on there, then you would see that I had actually in my pull request, I actually went in and changed this like HTTPS registry npm.js to get the MS package into github.com in a repository that I control. So if you did not review this, what would happen for you next if you were working on this project and doing like an npm install or yarn install after keeping up with the project development as a developer? It would actually be pulling in my version of the MS package and basically be able to compromise you in that sense. So now we actually need to understand that people can hide backdoors here and some other malicious data that they want. So we actually need to go ahead and this is another security concern when you use log files. And so luckily there's a tool for this. I built this thing called logfile.int, which helps us go ahead and have like security policies and say make sure that everything is coming only from npm and yarn, do not allow GitHub, or validate that everything is under HTTPS and nothing is not HTTPS, etc. So all of this is good tooling that helps us out. Let's see an example of code injection. Let's talk about actual vulnerabilities that that appear in the ecosystem. And so I wanna go out of like of the presentation mode, and I want to show you an actual vulnerability. So let's say this is our app. Let's hope that it will. There we go. And we have it. This is a very simple to-do application. As you can see, I can add some stuff here. Doesn't really matter, but it has this, this about page, and I think it even has this about new kind of route that will give us about data. And the way that we built it is using something that's called a templating engine, like Pug, like EJS. In this case, we used something that's called Dust.js, and it takes all of this device variables like desktop or mobile, and so it can give you kind of like the dynamic sense of building the page. And so the way that this works is, if you look at the actual code, you'll see that it has this condition where device equals device, and then it will do something here. And if I take a look at what happens in terms of, well, is Dust, which I'm using here, is actually secure or not? So my version obviously is not, since I'm using actually the vulnerable version to show you the example here. You can, but see, like, what is code injection and how does that look like, which is what I'm trying to like make the point here. So just to educate you on how this actually manifests. So if you think about it in terms of Dust itself, this is a very, actually it's intended to be a very secure library, and you can see like the dependency in a way that it manages data. And so it has this escape HTML, so it allows us to actually escape data, and it checks if something is a string, and if it is, it will go ahead and encode it, and so on. And so for me, if I wanted to go ahead and see what I can do is maybe I can go, since I know there's an evil going under, I could go and add some escaping characters to escape it, which doesn't really work. But the thing is, to exploit this, you have to understand a little bit more. So what is going on here is basically a thing that's called HTTP parameter pollution, which means I will be able to impact the way that the device character works. So it's not longer a string now, it's an array. And so it kind of behaves the same. As you can see, nothing was broken. But as soon as I add something like an escape character, this messes things around. And what happens behind the scene is that evil gets broken. So let me show you how this looks like from the command line perspective, that you can see how I am able to actually inject something into this website. So basically, this is a website. This is like the same query that we did before. If I launch it, I'll see some input, and on the left, you'll see there's a console log I'm doing in my request. So this is okay. But as soon as I know that there's like a code injection there, and I can know how to exploit it, I can send something like, I will terminate this whole eval statement here, and I will go and fire off a function, and then I will continue the rest of the statement so that my code won't get broken like it did when the evil like misses this single quote. So when I do that, you see that it kind of like looks like nothing. We did nothing. But if you look again on the left side, you'll see that now this console log shows you what I sent, and also actually executed console log 1. So at this point, I actually executed data on the server, JavaScript on the server that was evaluated in runtime, and I could have just as well done things like here, like send the payload with require process, like require a child process, execute some commands, or get me some sensitive files that you have, or whatever I wanted to do basically on this server, I could just execute it with the permissions and privileges allowed to this web server. So there's more on this vulnerability if you want to see like the actual details and go into it. I'll be happy to review more of that afterwards as well. So let's go back to like the silver linings in the ecosystem, all the control and what we have so far, around all of this, around all these security stories that we talked about. So first of all, how many of you have 2FA enabled to this date? Because it has been there since the end of 2017, so for a long time. And by now, you probably should have 2FA enabled in your account. The stats that I collected, at least from like somewhere around like last August or so, so it is a bit outdated in a sense. But I really doubt it goes much higher than a 10 or 15%. So this is the data that we had public since then. And this is what we have to work with, right? Only about 10% or maybe 15% if we want to do a visual thinking here of people having leveraging 2FA. So please, if you haven't understood that message from me so far, please go ahead and enable 2FA accounts, 2FA in all of your accounts on NPM on GitHub, so that we are all a little bit more secure. You can do it from the CLI as well as from the UI. So whatever works. Other thing is 2FA, it has some caveats in terms of, well, if you want to do automatic releases with things like semantic release, then you need to be able to provide the tokens, but that doesn't really work if you have 2FA enabled. So if you really care a lot about this issue, you can go to the package maintenance working group. There's an issue about it, and like participate. And if you want to offer some ideas, hopefully you are using something like npm audit or Snyk, whatever works for you again. In your workspaces. So this is like one good example to go ahead and stay up to date with vulnerabilities. What Snyk makes it a little bit easier is just in terms of if you do integrate with that, then it will actually create CI integration, like a pull request into your like a CI into your pull request. So basically, anything that gets opened as a pull request will get validated in terms of like maybe there's like a vulnerability being sent, and so it will break the build, and so on and so on. You might be wondering, are we seeing more or less security vulnerability issues for Node.js? So for the last couple of years, there's definitely a lot of tremendous growth, that, as you can see here, in terms of the vulnerabilities being reported for the NPM ecosystem. But this actually isn't specifically a bad thing. Actually, it's been cited by Zimmerman's security research that this is a sign of a very healthy security ecosystem, that actually, people care to report and process vulnerabilities, as when they get discovered as well. So this is a sign of a healthy ecosystem. This is great that we are having all of these conversations, all of these talks around security ecosystem around NPM and JavaScript. If you do want to join us, this is kind of like doing a full circle and a closure here. Is there's the Node Security Working Group. Has been established since the late 2016. It is comprised of people that are very passionate about security and open source. So we meet regularly. It's all being broadcasted, very open. If you want to take part, go ahead and check the Node project. So Node.js/security-wg, or just ping me or find us. It's not going to be hard. So we're all part of this like developer awareness. So I want to thank you all for being for joining this session. And if you have any questions, I think we'll go into this now. So that's all for me.
Yeah, exactly. Thank you for this amazing speech. I'm pretty sure that people liked it. And yeah, I've already sent a link to the Q&A room. It's going to be right here. Okay, so you don't have to leave. And yeah, I hope that people will connect it. So last but not least, we are going to have a soft skills section, but it's going to be a bit on the other track. That's why we are going to place the link somewhere in the chat. So you are free to join it, just because these topics are really amazing, really, and very relevant due to the situation in the whole world. Yeah. And yeah, but unfortunately we are done with our React and Node.js track. So I want to thank you all for being with us, for leaving your comments and listening to the speakers. And for sure, Liran, thank you for being with us as a speaker and having such a nice presentation.
Thank you for inviting me.
Thank you. And of course, sorry for some technical issues as we are doing for the first time. That's why you can't make it perfect for the first time. So I hope the other times are going to be much better. So yeah, and be safe, stay at home, just not to infect the other people or not to infect yourself. And yeah, thank you for being with us. And don't forget to join the soft skills section. So yeah, right now we have the Q&A, which is here, and soft skills topics link. It's right in the YouTube. Let's open the chat.